Alright, co-pilots and pilots, when you get settled, I can walk you through the plan, but we're approaching bottom pretty quick. Yeah, very flat, very flat. Expected bottom is 1625. So, bearing to waypoint 2 is going to be about a 3:15.
Coming down. All right, let's get bottom. Delta 17. Come down a little further here.
Bridge, this is RV Nav. Wanted to inform you that the vehicles are on the bottom, and when you have a second, I would like to discuss a bailout plan, please. Bailout plan will be set to southeast, please.
0.
And also, if we could have the center of rotation changed to the A-frame at this time, please.
Still rising.
Excellent. Thank you very much, Bridge.
We took a let off. Oh, we did? Yeah. Ah, okay, copy that.
We have reached the seafloor, and we are going to let our ROV pilots get set up, and when they are ready to go, we will continue on our track for today.
23 down. Okay, so it looks great. There's football 1 and football 2. Fiber numbers look good. Comps look great. Pushing down.
Alright, pilots, when you got a second, I can walk you through the dive for the day.
That's all right. Let's just get rolling here.
How you doing, Brian? You good? Awesome.
Sea ice is pretty close. All right. Let's get a move going.
Okay, first move will be 20 meter, probably 30 meters. It's pretty flat in here. 30 meters at a 3-2-5.
325.
325, copy.
Coming over just a little bit here. Okay, I'm lined up pretty much. 325.
Right, I will call it in. Decimal 2.
Thank you, Lars.
Bridge, this is RV nav. Can we have a move when you're ready? Range is
Get your lights
30 meters. Bearing
Perfect.
325 degrees. Speed 0.2 knots, please. Good copy, thank you.
Okay, now we can look at the plan. Sorry, just was already getting stretched.
Alright, pilots, I'm going to zoom out on HiPAC.
Yep.
So, today we have 8 waypoints. They're all suspected Seep targets that were mapped last night.
Okay.
We will make our way, starting off, we'll go to the northeast from waypoint 1 to waypoint 2. And then we will make our way, northwest, and then we'll make our way from waypoint 2 northeast to waypoint 3. And then we'll make our way northwest from waypoint 3 to waypoint 4. And then once we get to here, we have 2 more Seeps. There's waypoint 5 and 6. However, we may want to have a discussion on whether we want to go to 6 first and then up to 5. Instead of backtracking a little bit, we can discuss that.
Right.
And then make our way north to 7 and 8 as we go throughout the day.
Okay, so the first 2 or 3,
the first
3 are all flat area.
Exactly.
Okay.
So waypoint 2, 3, and 4 are all suspected Seeps and relatively flat.
Okay.
So
sounds good.
that will be. Right now we're going from waypoint 1 to waypoint 2. Waypoint 1 also could potentially be a Seep, so as we make our way over there to waypoint 2, keep an eye out for bubbles or any anomalies in the sonars. Which, speaking of that, I will drop pilots down to 30 meters.
Great. Yeah.
And
Nice.
co-pilot, you want to keep yours at 50?
Yeah, I think that's fine.
And can you adjust the gains on the pilots on our
Lights are out.
copy?
I got them straight right now.
Okay.
I can tone them back if you'd like.
No, I like it like that.
Okay.
Straight looks good. It's pretty flat. We want to throw a little more light out there.
Okay, gains are adjusted.
Okay, taking a scan out this way, looking for any possible sonar anomalies that would indicate seeps.
So as you guys can see, we are on bottom. Our pilots are on our way to our first waypoint. Looks like we have some mussel shells scattered around the seafloor.
Yeah, pilot, when you're ready, we'd like to zoom on some of those to confirm that.
Oops, sorry, I heard you talking in the back there, but I had OKX. I wasn't listening to OKX yet.
That's fine.
Repeat your last.
Yeah, if we could just zoom on some of these mussel shells that are, or what appear to be mussel shells on the seafloor, the white.
Yeah,
Please.
I see one that's sort of sticking out here on the right. That looks very mussel shell-like. Okay, Brian, you can start in on the shell here. Not large. Some lasers on.
Yeah, they do look like mussel shells. We are seeing a lot of these dead mussel shell remnants, and as well as these ophoroids that are scattered along the seafloor, but not amongst what look like live mussels at the moment. The bottom is pretty sedimented, but it's also rather rubbly. And we have a gooseneck barnacle.
Yeah, we could come in tighter on the barnacle.
If we could actually focus on the brittle stars up top, that would be helpful.
Okay.
Thank you.
Yeah.
Just off to my starboard.
Copy.
On the move. How much have we moved? Yeah. How much is serious move, you think?
Stand by. We are 25 meters of 30.
Copy.
So 5 more meters than we should be.
Can I turn, you want me to turn your aux light off in the back?
Yeah.
That's good. Thank you, pilot.
Great. Come wide, Brian. Come back around.
Oh, right
Yeah.
at the lasers. Can we take a look at that?
Sure can. Snap in real quick. Turn to keep
It is
the
a
view.
dead mussel. It just looks more recently dead than the...
Copy that, bridge. Thank you.
Urchin on top of it.
Pilot's at moves complete.
Thank you.
Okay. Thank you.
All right, coming around.
A few small anemones.
Yeah, so we said earlier as we were approaching the bottom that we are off of Norfolk Canyon today at a deep seep site. Looks like maybe we have a halosaur fish.
Alexis and Amy, this is Tim Gallaudet dialing in. I'm the Deputy Administrator at NOAA. I think you correspond with me a little bit.
Yes.
Good morning, Admiral Gallaudet. How are you?
Keep you in view.
Oh, I'm really good. I've been delighting every day in your expedition, and I just want to let you know it's really timely today, your last dive. I'm actually heading out in a few minutes to go to the White House. They've asked us to have a meeting to talk about the ocean exploration program and potentially elevating it to a more national program. So pretty excited about that, and I'll be live streaming from your ROV in the White House as I speak at this meeting. So thank you very much in advance for giving me some ample ammunition.
Well, thank you so much for all of your support of NOAA and ocean exploration. This is really a great honor to have you call in and for us to be live streaming at the White House today.
Yeah, definitely. We are doing some real exploration today as we're getting to look at a new section of a seep site out here in the mid-Atlantic that the original data from the water column was also collected by the Okeanos Explorer and analyzed by scientists at Mississippi State and USGS. So really great partnerships that have been able to develop over the years, and excited to have you guys with us today.
Admiral Gallaudet, this is Carolyn Ruppel from the U.S. Geological Survey. I'd like to just say that from our perspective, here we are on the 100th expedition of Okeanos Explorer in the 10th year of the program, and the Seep story that NOAA OER has developed on the U.S. Atlantic margin is, as far as I think our group is concerned, the biggest marquee story that's come out of the ocean exploration program over the years. And so it's very fitting that you're going to go to the White House and you're going to see us back at the place where Adam Skarke and others at NOAA started this whole story. So thank you very much for your advocacy on behalf of the ocean community.
Oh, my pleasure. And thank you for highlighting and reminding me of those milestones. Those are very, I think, important aspects to bring out today. And I'll be meeting with your director, Dr. Riley, next week. So we'll certainly want to highlight this expedition and our partnership during that meeting. So wonderful news to hear. I have to sign off right now, but I'll be watching you and supporting you from a distance.
You want to get a closer look at?
Thank you, everybody. Thank the entire crew and our partners, especially with GFOE.
Thank you so much for calling in.
Oh, we can come
Yes,
out.
that was
I think we got
great.
some
And
good,
our
good shots of
pilots
this.
are busy working, but
Thanks.
they're excited to be here with us from GFOE as well, and our video team.
Got a small boat. Port side.
So
Wonderful. Thank you.
we can continue on our track, pilots.
Continuing on.
I turned 90 degrees.
Copy. So, yeah, I saw that coming around. Still dialing in Z-bias a little bit.
Copy. Where are you at? 25?
Yeah, 25 and a half now. 26, I'm on the bottom. 25, I'm floating pretty good. So. Got an Oreo fish or something maybe coming up.
Coming to port with you. Reverse
hake.
slightly.
It's a hake. Looks shorter and stubbier from afar.
Can take a quick look at this fish.
I'm slowly turning to port. Be advised.
Thank you.
Keeping you in the frame.
You can come in partial video. Hold there.
Great, thank you.
Yep. Okay. Unless you want a tighter shot video, we can move on. Thanks.
Okay. Looks like I'm
And
looking
Mike Vecchione says
northbound.
that's a blue hake. So thank you for that ID, Mike.
325.
An
is the magic number.
Antimora rostrata.
Coming to port a little bit. Set point 330. Okay.
So we are exploring a bit
I'm at
to the
325.
east and to the south of where some of the larger plume areas have been explored before. Oh, that's an umbellula, a sea pen.
Where's Chris?
Yeah. Can we just take a look at this coral real quick?
Yep. Yeah, I'll come around to the polyps faces here.
That'd be great.
Umbellula.
Umbellula.
I always get excited when we see corals around
Come
areas
in.
where there's seepage
frame the
nearby,
video.
because there is some work going in to look at if certain corals are able to actually incorporate the methane signature into their tissues, or are they processing bacteria that are processing the methane. It's still very much ongoing, and there's a couple different species in the Gulf of Mexico as well as off of Costa Rica that are currently being actively studied in this
Yeah,
regard.
this looks
But
good. You can start coming in.
it's interesting to see a sea pen
Ooh.
just on the external edges of likely inactive methane seep.
It tried to get that.
We saw this before when we saw an umbellula, that there seems to be these mysid shrimp that like to hang out right around the polyps.
Fish by
Yeah.
your left tail. I think it might be the same one.
Another blue hake.
Yeah. I think it's close to the ground. Going underneath you. Yep, just hanging out.
Yeah, so we saw one of these umbellula a few dives ago, and with this same kind of these mysid shrimp that were sort of swimming around the tentacles, which seemed like a very precarious position to be in.
Okay.
Great, thank you so much, Pilot and Video. Continue making our way towards our next waypoint.
I'm lined up.
Great.
How do you feel about another 30-meter move? We're about 40 meters away. Sirius is about 40 meters away.
Okay. Sounds good.
Another 30 meters at a 325.
Copy.
Bridge, this is RV Nav. I'm ready for another move if you are. Range 30 meters, bearing 325 degrees, speed 0.2 knots, please.
There's a large rock, it appears,
Good copy, thank you.
and a big fly trap anemone.
Just coming partial video from here. What do we have?
I think
Are
that's a
those-
bag.
Yeah, that's what I was trying to look at, like some type of...
Are these shells alive or dead?
Yeah, those shells appear to be dead.
Okay. And some kind of, bag of sorts. Not unless science needs it.
No, we don't need it. Thank you.
There is a little anemone right here next to the bag. Commentate on that real quick. Let's make sure we catch that. Tube anemone or something.
Yeah, it looks like a little tube anemone.
Okay. All right. Yeah. Yeah. All right. Get mosey on, I think. Thank you, video.
Yeah, probably a piece of trash. And I was looking through some of the wonderful feedback and comments and questions people have posted on our social media sites. And one of the things that I noticed is a couple people have mentioned about picking up trash. And while we look at this and it is somewhat of a scar on our seafloor, the anthropogenic input, you can see that there are a lot of organisms that actually use this trash that ends up on the seafloor as habitat. So they either grow on it or burrow underneath it, use it for protection. Yeah, this looks like a tied up trash bag. And so we actually do not pick up the trash because we could be making a negative impact on that ecosystem that's inhabiting that particular piece on the seafloor.
So come on, move.
Okay, pilots, it looks like another 5 meters left in that move.
Okay.
We should be getting pretty close to waypoint 2.
Okay.
Pilot, for reference, it should be off to your port.
Right.
From the RV, looks like 316. From me, 325, right dead ahead of me. I see you, but I don't see anything else.
Right. I gotta do a big swab through here and just make sure that we don't miss it. Explore.
Do you want me to try and do a higher resolution on the sonars, or do you think that will help?
No, I think I want it scanned quickly for now, although we should try the higher resolution once we find it. That'd be interesting.
Good idea.
Go ahead, watch one. Okay. Okay, so we're looking for signs of the previous
Cover that bridge, thank you.
site. Right. Okay. Sounds good. Well, we will keep an eye out for it. It's good to know I'm not looking for bubbles or just
Oh, there's the third
a
one.
field.
Yeah, the seeps that we are potentially going to encounter today do seem to turn on and off, so
You should
we
be
did not
just
observe
about right over that waypoint
plumes
2.
in the seafloor,
I have waypoint 3
plumes coming from the
selected,
seafloor last night
but
in
pretty close
this
to it.
direct point on our track, but we are going to work our way through a couple points that were observed historically to be seeping, and by historically, like 5 years ago, so not very
Coming
long
down
ago.
a little bit. Use more
And
time.
then work our way to some that were actively seeping last night when we mapped this area.
Okay.
Yeah, and this is Adam. I'll point out that the presence that we keep seeing of the dead Bachymoleotis shells on the seafloor suggests that we are pretty close to a chemosynthetic ecosystem. And so seeing these dead shells is pretty typical of what we've seen before when approaching a site. So that's a good sign for hopefully upcoming more robust communities.
Yeah, thanks, Adam.
Is it
And
spider?
Fish in the
Big
background.
picnic gonid.
Hey, can you zoom way out their video for me real quick? Bring up the light a
And
little.
this is Carolyn. So, you know, on this margin in particular, it's
See what it is.
generally been true
Video
that
zoom?
some of the deep seeps, the ones say deeper than 1,000 meters, seem to just
We have-
keep
it's a chimera.
going
Okay.
continuously. And I think you saw that in the overnight mapping and sort of the main
There,
seep field that we've
there's
known
a
about
sea
since
spider
2012. Seen that up in the Chincoteague
Okay.
seeps. But other seeps at this depth, and Adam's worked on some up in Beach Canyon
Yeah,
on the
good.
New England
Thanks.
margin, do
Just making
seem to
sure it
turn
wasn't
off and
something
on.
we haven't seen
And
before.
so on the cruise we just finished on the Pacific seep, the seeps, even the deep ones, seem
You wanna
to
continue
turn off and on
to
due to tidal
explore a little
influences.
past
And you might not
Yeah.
Waypoint 2, or
think
would
that
you like
something
to turn to
at
starboard and go
1,300
to
meters
3?
water depth
Kind
could
of
be
set myself up
influenced
to do a
by
across
a very
1.2
small,
as we've hit
relatively
3, I
small
think,
tidal
so
range. But in fact, it
take a
appears that they
glance
can.
as we go.
And
then
so that same thing may be
head
happening
to
with
3.
some subset of the seeps that we see
Copy,
on the
3.
Atlantic margin, although at least in my experience over the past 5
Seeing
years,
shells,
it doesn't
etc.
seem as ubiquitous as it does on the Pacific
So
seeps that we worked on off Cascadia.
extinct long enough that
So you 30 meters radius. Your sonar looks.
That's great background.
You
Thank
looked.
you, Carolyn.
Okay. So to waypoint 3 from me is 040 bearing.
All right, we're crossing across the waypoint 2. Potentially the one that you saw seeping a few years ago that is not anymore. And obviously we're seeing some old shells, but not much else here. So we're planning to continue on to 3. Is that good, or do you want us to investigate around here further? Watch lead. Sorry, are you muted? I can't quite hear you.
Oh, sorry. Now can you hear me now?
Yep.
Okay. Yeah, I think it's good to continue on to the next waypoint.
Okay. On to 3.
All right, I got to turn to starboard to 040.
I think as we were talking with
So
Adam and
all the
Carolyn, there
tether you
was a
got.
chimera in the
Mhm.
distance, right?
Yeah.
There was, yeah.
No, that's a hake.
I took
Blue
the
hakes.
liberty to zoom out on it for you.
Yeah, thank you.
I see the Sirius lights in the
Oh, yeah.
port minute. It's fun. How you
Hey.
doing? We might have another chimera out
Yeah.
there. It was
Yeah,
an umbellula.
What is your favorite?
Come on in. Video. Okay, sneak a
Why
little
is that one
closer
your
to this.
favorite?
This is the
Yeah.
reaction.
Looks like
Yeah.
a different
Really?
chimera than the one we saw
I like
previously in the cruise a couple
Yeah,
times.
yeah. It was more brown and white spotted previously, I
the name.
think.
Swimming right along.
I'm turning to starboard.
Copy.
Yeah, Nav, why is Umbellula your favorite?
I think we just like the name.
Yeah. It's fun to say.
Yeah.
It's so nice to watch chimera swim. They're just so graceful.
It's pretty
Yeah.
quick for a chimera.
All set. Yeah, he was cruising.
Yeah.
Or she. It. It was cruising.
All right, I'm due north and slightly eastbound here. We're gonna
Are you lined up?
not quite yet. I gotta go to 40
You gotta go further starboard.
Yeah.
Okay. I'll keep coming
over
around.
here.
So is the idea to head to waypoint 3 then?
Yeah.
Yep. Yeah. We can get a move in that general direction.
All
Is there a
right.
lot of targets in between 2 and 3, or should we just call a big move right to it? Watch lead.
I think there's not targets in between there. We'll keep our eye out, but it should be a pretty straight shot.
Yeah, you can. It's pretty downhill, so we can just go for it.
Okay.
Yeah.
And I guess you guys surveyed all around here.
Yeah.
Okay. Copy. All right. We'll do about 35035. I'll get it in now.
Great.
Probably just start at 100 meters.
Sounds good. Sure. Can keep up with that. Just be ready to stop it if we find something cool. So you can come in partial on this eel video. Tilting down to it.
Move on the way.
Thanks. Alright. Let him swim off. Yeah, I don't want to wind around too much that far. Get my tether near my swing arms. What do we have here? Just a rock or something?
Yeah, let's take a look.
Come in a little bit, video. It's a shell.
It is a shell, but you can see that the two halves of the shell are open, but we don't see tissue coming out. So likely, very likely, a dead mussel.
Okay.
But just to the left, there was a lighter colored shell. Could we just pan?
On the top of the screen right now, or even further?
No, it was like yellowish,
Okay.
or like more, yeah.
Oh, okay.
Just
yes.
to look at the different color.
Absolutely. Can you come in as I bring it center, video?
These brittle stars like to hang out underneath.
What is
Alright,
that on the
little spot.
right side of it?
It's like a little tiny urchin there.
Oh, it is. It does look like a little tiny urchin.
Yeah, but on the in the sediment on the
Oh.
right.
Oh yeah, I don't know.
Yeah, video, you can come in a little tighter. So I'm going to get in a little closer and tilt down and see if I can't get a better look. It's moving, whatever it is. Oh no, oh, I'm full down. I just realized. Okay. That's as close as I can get. You can come in tight. See if we can bring out some detail.
Oh, it is moving, whatever.
Oh.
Oh, it's just the override moving,
Yeah.
whatever that
Yeah,
thing
it
is.
Yeah.
Okay, we can carry on.
Okay.
Thank you.
Thank you.
It's gonna pop out from under his shell. Say hello.
Well, actually, this move is, I think, slightly downhill. So we put in a 0.3 move that was 100 meters long, so it's going to be moving right along. But if you see something, call it out. Otherwise, we're making our way to waypoint 3.
Yeah, that sounds good.
In a hurry,
Yeah.
if you will.
Thanks.
Yep.
Sirius is on the move.
Yeah, as we pointed out earlier, we don't expect to see any active seeping. At least we didn't on our overnight mapping between these two waypoints, but we are looking for evidence of past seepage.
Yeah, we can stop moves easily enough and take longer looks at things if you need it.
Okay, thank you.
Just let us know. Otherwise, we'll be moving along.
Should be 11 minutes for the ship to get there. That's pretty quick.
Yeah. Can come in a little bit video on this. Fish. Perfect. Thank you.
Chimera's about to come from your port. Just
Oh yeah, look at that. Come out real quick, video. Video wide.
Oh, nice. Just cruise on by in front of us.
Blue and Chimera in the same cruise. I'm happy. Or in the same dive. I'm
dive,
happy.
yeah.
That's all I need.
Me too.
I'm waiting for the Chrysler Gorgia. That's my favorite. I don't know if we've seen that recently or not.
Which Chrysler Gorgia is your favorite?
There's multiple. I don't know.
There's multiple.
I'd have to look at it,
There is.
and then I would know. I don't know the name.
Do you like the genus or the species Chrysler Gorgia?
I didn't.
How far down do you like to go?
I don't even know.
Chrysler Gorgia, Arita Gorgia. That's the cool one.
Yeah.
The spirals.
Those are. I like the fireworks one.
Oh, the bushy one. Bottle brush, they call that. I forget what the long
Looks like
name is.
Looks like the branching from all directions kind of deal.
Yes. Like the ones, the long
Column.
stem that it's a poof on top, or it's down low.
No, I like down low, like
Down low. So gotcha. Copy. Not as cool as an Ambulula, but cool.
Yeah.
Ambulula have very big polyps.
Yeah, I
Well,
like
so-
I like the defined polyps.
Yeah.
That was a nice specimen you found. I was admiring.
Thank you. A little brown. I like it when they're the purple or bluer colors.
Yeah.
but
Not optimal, but
yeah, but it's good.
That our Paragorgia Fest 2019 yesterday was pretty awesome.
Yeah, it was all right. Just kidding. It was amazing.
about halfway through that move, pilots.
Copy.
Copy that.
Sonar looks pretty clear on Sirius.
Yeah, so you've got you switched them. It's probably smart.
Yeah, what's to the left there?
Yeah, I'm just coming around for it.
Excellent, thank you.
Coming into the more downhill section so we can get a little closer look at it.
Looks like an octopus.
Is it now? Oh, it does have long arms, doesn't it? Wow. It's hanging out here. Yeah, you can start coming in just in case. Oh, his face is over there.
Oh, it sure is.
Coming in closer. I'll tilt down a little just so I can get right in here. Very dark arms.
Yeah, and 2 rows of suckers.
It's maybe a Bathymotilus, or no, sorry, no, that's the mussel. Bathypolypus.
It looks a little bit big and to be a bathypolypus. Might be a muse octopus.
Oh, maybe.
Yeah,
those
muse
eyes.
octopus johnsoni.
Okay, good call.
Those cool eyes. Alright, now with the lasers, got those on it. Sneaking in a little closer. Hopefully it will play nice here.
A couple days ago we saw one. We saw another type of octopus brooding its eggs, but there was at least one individual of a musk octopus that was also brooding its eggs in a canyon.
Yeah, if you've got it, come a little tighter.
Oh, that's really interesting. Michael Vecchione says that it's unique because it has a reverse counter shading. So the counter shading is usually dark on top and light on bottom. But as you can see, this one is light on top and dark on bottom.
Am I still moving? Chris? Is the ship stopped or is it still going?
No, still gone.
Okay.
Probably why it sits
Alright,
there
Jeff,
and kind
I
of
got you at 75.
curls
I'm
its
still moving.
arms
be
up
advised.
sort of over
Gonna
top
take a
of it.
second of this, and then we should.
It's also a kind of hiding position.
If it swims, just let them swim. We don't need to adjust zoom. It would be a cool shot to have them swim out.
Looking down at you. 90.
Okay. I got 2 more seconds and I gotta go. Alright, off we go. Next video.
Yep, got about 15, 20 meters more.
Okay.
We are on the move. Trap enemy.
Pretty flat here, huh?
We have a
Yeah.
fish just on the top left.
Yeah,
Oh,
can get a look at that. Coming in partial video. Hold there.
Thank you, Bridge. Okay, pilots move complete.
Yeah.
Roger.
Can we have lasers on the way out, please?
Yeah.
Mike Vecchione has identified that as a slick head.
Ooh, there you go. Nice.
Got it. Yeah.
I don't remember seeing any of this.
Yeah, I don't remember seeing, especially a close-up of any of those thus
Okay.
far.
I'm up kind of high. I'll let him go video.
Looking down at you. 9-3. Got maybe 5 meters left to swing or so.
Okay.
That was the guess.
Push down back to the bottom.
We can put another one in if you guys want. That left us a little short. I just wanted to make it a nice even number.
Yeah.
Yeah,
Wanna
we
just keep going.
should get another. Let me just get a little caught up here and then.
Okay.
A little more caught up.
We'll put in the next one will be 60 meters. 60.
Okay. You haven't had to change your heading or anything, right?
Correct.
Alright, cool.
Still on the direction of movement here. Looking right at waypoint 3.
Copy 3.
I came up just a little bit. I can come back down.
Still comfortable with point 3? I think you did okay.
Yeah, I think that was good for this.
What is this here in front of us?
Not sure yet. Getting in a little closer.
Thank you.
I'll wait to put that in.
Yeah.
Thanks.
Sounded like a magic conch, but I think it was a chair or something on a deck, right?
Or dab it.
Dab it, yeah.
Have it? Oh. Yeah. Copy.
Understood. Thank you, Bridge.
Alright, you can come in a little bit video. We got a jelly on the bottom too there.
I
Oh
noticed
yeah.
you don't have constant craft
Looks like
control
a
on
tube
cycle.
anemone.
Thank you.
So these tube anemones are not actually like the other anemones we see. They are a different order, I believe, and they have a
I should be settled out, but I'm looking back at
brown,
Okay.
a set of oral tentacles as well as the outer tentacles. We often see them in these sedimented areas.
Just. Yeah. Can you kill my lasers for me?
Yeah.
These are occupied. Thanks. Since this is floating by, I think we get a second of jelly and then come back to the
Oh, yeah.
you. Oh.
anemone. It's all the way down on the cameras.
Just
Scooting back a little. Just to bring it in view. Okay. We're going for the jelly, just because it's floating. Can come in a little tighter. Thank you. Hold that.
that's nice. Going to do a little turn right in front of us.
Yeah, you can take it.
My rotator's maxed out. You're just off screen. I'm going to find you and tighten. Just finishing my swing here, I think.
Copy.
Here you are.
Okay. Do you need a little more time with this anemone, or is it alright if I catch up?
I think we're good.
I can get a tighter look at
I'll
it
say
if you'd
as
like.
we pull out, Scott France says that they have special night assists that are used to build the tube, and they incorporate mucus and the surrounding
Track
mud. So
focus
that's
to
how
the
they
anemone.
form that outer tube, which we don't often see. They're generally
Yeah,
open and
come in
kind
a
of
little tighter on
or
it.
the tube isn't very long.
It's all the down tilt I have, so. Okay.
That's great.
Off I
Thank
go.
you.
Thanks, video.
I got the craft controller up. You
Thank you.
can zero the air, then you're good to go.
Awesome.
You want me to take care of that?
Sure. Yeah.
Yeah, I can see your light pulley right here.
Copy. Light pool.
I have visual.
Good.
Is that another trash bag?
More debris, yeah. Looks like it. Unfortunately. That looks like. Yeah.
Yep, another trash bag.
Won't go back to the honeycomb.
Oh, okay.
I think it.
I guess normal, right?
Yeah, I think so. How are we looking?
You're still
Yeah.
a little behind there.
Okay.
Yeah, a little behind still.
Yeah, actually, that I'm glad you did that because that move it won't be 60 meters. It'll be a lot less, 40,
Copy.
which is good. Yeah, I think your swing was increased because we went a little faster. Kind of got out there a little bit.
Yeah.
All right, so it's right ahead of D2. 34 meters from D2. Your sonar is looking right at 30 meters.
Okay.
Like watch two's calling
Ready?
you. Man.
Watch two's calling you.
Oh, really?
Yeah.
Maybe they're turned down or something.
Oh, they're at minus 48D.
Oh.
That's a good place. Go ahead, watch lead 2. We have, but I think we're just shy of 200. Nope, that's negative. We just passed 200 a few minutes ago. I will make a target here for you. Yeah, thanks for the reminder, Watchley.
Bit of a bump and then a harder return. I'm going to go scope out that. Yeah.
Copy.
Just off to port. Another chimera swimming in.
I think that's you, probably, right?
Yeah.
Yeah.
I agree with that statement.
There are those anemones
Oh,
on the
sorry.
Yeah, it
bottom.
looks
I
like
think?
it.
I'm
Chimera coming
staring
back
at my sonar instead of the screen. You want the bright orange or these darker, long tentacled looking ones?
The bright orange.
Okay.
I just want to see what that pile is.
Yeah, coming in on the little pile here video of
The center up your mini zoos. That's what I do.
various creatures. What are they on? Okay, come a little tighter.
We have a couple different types of brittle stars up on this maybe rock-ish.
Maybe some, yeah.
Strain relief.
Copy.
Yeah. Nice.
So Jeff Lanning.
I like it.
You can come in tighter, yeah.
Okay.
Backing up a little for you.
There's some tubes to the on there. Okay, that's good. Thank you. Those ophoroids buried in the sediment too.
Good to go.
You guys want that move?
Yeah, you might inch just a little closer. My main target here is still 20 meters out, so
Okay.
yeah.
So you want to, I originally was thinking 40 meters. You want to just do like 30?
Maybe 30's better, yeah,
Okay.
just so we can investigate
Sounds good.
this area. Got a few returns on the sonar right out this direction. Just a little out of reach, but we will head that way.
Sounds good.
Returns are a little stronger, so that would indicate some hard bottom maybe.
Oh. And we have some bacteria on the sediment down here in the bottom left corner as well.
Yes.
And
No,
then
yeah,
absolutely.
up
Amy's,
off the very top
Yeah.
there.
yeah,
I think what we're just seeing at top of screen is the sonar returns.
great.
So we'll head over there in a moment once we get a move going closer, but we can take a peek here in the foreground.
Yeah, if we're just waiting on the ship, go ahead.
Yep. Okay, come on in, video.
Move is in. Copilot, let me know if you want to cut it a little short. 30 might be.
Yeah, I can see it. See
Yeah,
that
our
quick
first
D2 there. I think 30's probably good.
indications
Okay.
of some active seepage is that there's a bit of bacterial mat down here on the sediment.
Copy. I think this is good framing. Anything you need a closer look at? Launch lead.
We can go in closer if we have time. We'll
Yeah,
just go kind of
absolutely.
as close as.
Come in full. We'll scan around. See what kind of bacteria is in here. Is that full zoom? Ooh, a little more. Very nice. Thank you, video. Okay. Come out a little bit. Oh, there's a little wider, darker, wider spot there.
Go ahead, Nav.
Oh yeah. Sure, you can have a quick one. I'm floating. Oh yeah. Very small. Okay, come on out.
Yeah, it is. The seafloor is very lumpy, which Bob Carney pointed out in the chat, and I don't think I don't think that we think that they're rock chunks. They just look kind of like consolidated mud. But we'll see if they continue. I have a feeling if we tried to sample them, they would not stay intact. Another chimera. Man. They're
Lucky us.
everywhere today.
This is a
This is a quite interesting.
feature area.
Yeah.
Looks like there's some carbonate rocks there
and
as well.
some mussels.
And some mussels.
Got a chimera up here too with me.
Oh yeah.
There you go.
Scout one.
Eyes on.
Yeah, this is really interesting. There's kind of like a little valley, and up on the left side of this valley is a lot of
You can come in, you can
this
scan around,
chemosynthetic
just kind of frame
bacterial mat, and then
this area in general. See if we
it
can
looks
sort
like down
Are those
in
alive?
the valley we have some live mussels.
Oh yeah, they're alive.
Nice.
Do you want a tighter look on the mussels?
Yeah, sure.
Okay, video.
And
Come on
when
in.
we have a chance, lasers would be really helpful.
They are on.
Thank you. Yeah, there's definitely a patch of live mussels here. They're not too large, so possibly Bathymoldiolus childresi. It looks like actually a bit of that trash has deposited into. Oh, that's the pink thing sticking out is a holothorian, so a sea cucumber that we've seen associated with similar bacterial mats a little bit to the south where I've worked, and I'm curious in the chat if people are familiar with seeing
Thank you.
these same type of sea cucumbers at the Norfolk seeps that are just right around us. And then there's a different type of sea cucumber to the left that is very sedimented just on the outside of this area.
I see a couple more white spots.
And yeah,
Up here.
Cheryl Morrison said that, yeah,
you're on
they
the
have
biggest one.
seen the cucumbers associated with these mussels at the Norfolk sites.
I haven't seen any bubbles yet. Have you guys?
Negative.
Negative. Copy.
Let me know if you guys want anything on your sonars. I think they're pretty good.
Yeah, I think they're pretty good.
Okay, video. Come on out.
Looks like I'm just finishing my swing here.
Yeah, that's good.
Where's the next? Oh, there it is. It's up there. To our left a little bit.
Yeah, you can keep this. I'm just going to scan along.
Can we take a look at the brittle stars that are on the rock just around the
center
bacterial
here?
mat. Yeah.
Yeah, come out in video on those 3 or 4 little stars.
Possible chimera coming in here towards you.
Yeah,
Your friend.
coming for a photobomb.
Yep. Oh, he's turning. I think I finished my swing right over top. Yeah.
Thanks.
It's a cool shadow.
Just enough current that I have to like.
Oh, to start up.
I was going to ask you about that, yeah.
Yeah, you can come out a little bit video.
I can turn off your lats. Just axes.
Good work.
Vertrans.
Are you talking about the limit that you're seeing in the camera? It hitting its...
No, he's talking about the.
So we're currently
makes
at an
command
area
starboard,
on
Yeah.
our
and 4 motors
track
all
that
have to start,
we
and
weren't
it's
seeing
too much.
Gotcha.
plumes in the overnight bathymetry, but
It vibrates
we are
and it like
obviously
kinda
seeing
jumps you.
Yeah.
this active seepage happening. So while we often talk about how we find these sites and looking for those
Incentive
active
for solver
plumes,
feedback.
that doesn't mean that those are the only places that we'll end up finding these communities. And I think Adam and Carolyn have both communicated that as well over our kind of seep dives throughout this expedition. But it's an interesting thing for us to consider when thinking about how vast these communities might actually be out here in the mid-Atlantic.
That's a really good point. You know, it's on one level, it's very interesting because it speaks to the complexity of the fluid flow processes under the surface,
this
and
zoom,
exactly
come
what's
around.
controlling when and where gas
Another
comes
section.
out.
See the reflections up there?
But it's also a
Yeah,
bit
I've got some
confounding,
of the
right?
manip
We'd like
cams
to
over
be
here
able
too.
to use the water
Just
column data to say,
scan along here
well,
and then head over
exactly
there
where
in a
seeps
second.
are and how extensive they are. And what we're seeing is, as you're seeing here, is that in 2014, it very much looked like a bubble plume was coming out here, and we see clear signs of seepage, but the bubbles aren't on right now. They're likely coming out somewhere else. So Carolyn can probably speak better than I can to this, but there's likely an entire sort of plumbing system underneath this feature, and there is available methane, and it can get redirected to different points of discharge on the seafloor. And as methane hydrate forms and dissolves, so as it blocks pathways and then potentially dissolves to create new pathways, where the gas is coming out moves around. And as you said, that means that the extent of these environments can be much greater than what we might initially infer just from water column surveys.
Yeah, thanks for that, Adam.
Lots of bacteria.
It is really great on these
Or
seep
shells.
dives. We've had so much help from Adam and Carolyn, both planning and being on the line with us, and it's really great for Amy and I. You know, I've done a little bit of seep exploration, but it is so helpful to have the people really behind these types of explorations with us.
Okay. Got a couple other targets.
Yeah,
Not
and
so much
that's,
starboard, but
you
a
know,
lot of mud
these,
between here and there.
the
Some that
beauty
come
of
wide.
these NOAA ocean exploration and research
Come on out,
expeditions
video.
is that it is a very, you know, community-based science. You know, we are out for exploration and we are collecting specimens but they are for the general public. They're not for any particular person. And it's like, you know, these rocks, or if we collect a mussel, this is of sort of the general use and of general interest to learn more about these sites.
Got a big field over here.
That's exactly right.
Nice.
And sorry, go ahead.
No, go ahead, Adam. Sorry, I was just excited about more mussels.
I was just going to say that sort of Amy's point is that, you know, the work that Okeanos is doing here is really not the end of the exploration story. It's the start of it. Because so, as Amy said, the data is for the community, and so many members of the scientific community have taken it and used it to propose further follow-on research that's resulted in additional research cruises to these sites and further investigations. So it's really great the way that OER makes this a resource that can drive the science and supply the community with the preliminary data it needs to do really focused investigation.
Serious view gives you a good idea of the colony here. Group.
Yeah, so we've come upon another kind of patch of these chemosynthetic mussels, kind of surrounding what looks like probably a chunk of authigenic carbonate. There's a number of urchins that are on top of these mussels as well.
Do you want to take a look at one of the urchins?
Yes, please.
Okay. Start in video. Just gonna tilt down, get it all centered up.
Looks like waypoint 4 is back at 310. Chris?
That's affirmative,
A little
co-pilot.
tighter.
But he's seen a lot out that way too. And he's pretty hard return to port, which I don't think we've been quite that far yet. Yeah.
Copy.
So may as well explore those.
It's like 15 meters away.
Yeah.
I did take a glance at that.
You did?
Yeah, I didn't. I mean, off the distance, didn't get close.
Okay. I was just going to look up what the beam angles were, because it looks like this feature that you're looking at that ahead isn't even on your sonar. So I wonder if it's, since the sonar's up on the vehicle a little bit, I was just trying to get an idea what the slant angle is.
Chasing the birds here.
And if we could have lasers on the way out.
Yeah, I think they're on. We'll just,
great.
When we zoom out far enough, you'll be able to see them, hopefully.
Thank you.
This guy's maybe 10 centimeters.
And if you are just joining us today, we are currently diving off of Norfolk Canyon at a deep cold seep site. We are roughly at 1,615 meters water depth, exploring an area of the seep that has not previously been explored. So we had a number of targets provided from Adam Skarke and Carolyn Ruppel, and we are working our way through. We've made it to our third waypoint for the day and encountered a couple areas of chemosynthetic mussels as well as bacterial mats.
The lasers on this guy. There. Great. Okay. Come on a little more. Oh, there's Waltarian in there.
Yeah, this mussel
And a
bed
cup coral.
looks
Is that a
quite
cup-
different, I feel like, from some of... You see a... What?
Come in a little bit, video.
I think it's a hidden urchin.
Very deceptive. Almost the right shape.
Yeah.
Okay. All right, video. Thanks.
Yeah, Bob Carney made a comment in the chat that I was also starting to think about, is that these mussel shells seem relatively clean except for numerous old byssal attachments. So their byssal threads are how these mussels all attach to themselves as well as the seafloor. And these ones are not really coated in like a sediment or a detritus layer. They're all pretty exposed. And then we have, it looks like, a ridge of them that is covered in bacterial mat. There's a question from Twitter. They ask, what's the fuzzies on the mussels? And the fuzzy stuff on the outside is likely a type of, I think, tube worm. Not like chemosynthetic, but they essentially build little burrows. The brown stuff and then all the white fuzziness is bacteria, so chemosynthetic bacteria that's growing on the outside of the mussels. We have another question from Facebook. Why are the lasers important? So the lasers are 10 centimeters apart, and what that allows us to do is understand size down here on the seafloor. So with those lasers we can essentially measure what we're looking at, and that can be important for a number of reasons. So certain species are thought to be certain sizes, so you can determine what type of organism something is based on its size, as well as when the studies get done on some of these organisms later on, you need a size reference in order to describe that species. And similar with geology, it gives us a context for how big of a geologic feature we might be looking at. And there's definitely a variety of sizes of mussel, so it looks like there's new recruits as well as some of the older mussels. And they're very densely packed around what we just went through. You can see just how they're all growing on and around each other. They're essentially all attached, so if we tried to take one of those mussels from the group, a lot of them would come with them because they're all attached to each other with those byssal threads.
I have beam width numbers for you guys.
Copy.
42.
It's close.
47.
Lower frequency, 20
we have
degrees.
a chimera
Higher
hanging out
frequency,
in our
40.
mussel bed.
Copy.
That would explain why you don't see the stuff right in front of you on the
And
lower frequency.
Another octopus.
And yeah, good eye, pilot. There's an octopus in the background there as well.
20 degrees. Nice find.
Wow, this is really cool.
Looks like many of the mussels here are dead, at least on the right-hand side of the image.
Sorry, can you say that again, Adam?
It looked a bit like many of the mussels on the right-hand side of the field were dead.
Yes, yeah.
Not as many live ones as just around the corner.
Right. Yeah, the other ones looked so a lot less sedimentation on the other side, and we're seeing this side more of those dead shells and still some live mussels, but they are covered in a much denser sediment layer. And I think we're on to chimera number 6 today. Seeing a lot of them around this area.
Looks like you're close to the heading of the next waypoint.
Sounds good.
Want me to turn to port to line up to waypoint 4, 312?
May as well check it out here, though.
Yeah, I think we can start heading that way. Got a couple little things over here, but probably be getting moving on.
We can get a slow one in if you want. 0.2.
Yeah. Sounds good. How far is it?
We're
1.4?
a little over 100 meters.
Okay.
Want to start at like 40, something like that?
Yeah, sounds good.
Okay. We'll do 300 if you want to head that way, Levi.
Okay, watch lead. I think we classified this area pretty well. We were
Copy.
going to head on to waypoint 4 if that sounds good to you.
Yeah, that sounds good. Thank you.
I gotta come 30 more degrees to port.
Copy. How many more degrees?
30.
Okay.
Here.
Yeah. Okay, yeah, you can come wide.
There we go. I'm at 305. Move is called in at 300.
That was a cool sight.
Yeah, a lot there.
So much still alive, considering.
Do you know which waypoints they saw bubbles on the last?
I think 4 is the beginning of
4.
seek targets.
Yeah.
We
Stand
had
by one.
another question from Facebook, in that Amanda asked, "Is there such thing as female or male mussels?" And Jim Masterson provided an
partial
answer
video?
for this before we got around to it. Most mussels have separate
that's not
sexes,
much,
and
eh?
they are broadcast spawners, so they release the
That's
sperm and the egg into the
played a-
water
ha-
column,
played
and
trick
it's
on my eyes.
fertilized outside
Looked
of
like it took off
like
off the
within the
bottom.
water, and then the
Yeah.
juveniles settle and grow into mussels. But there are some exceptions that actually the fertilization happens within the female and are then released. But I think that's mostly just freshwater mussels where that happens. Oh, and some mussels are hermaphrodites.
Okay.
That's cool.
Copy. So it's just above waypoint 4. Is it?
Yeah, just so this is a little bit of a different orientation, but that line on the left is from 4 to 5. So I think that those,
Right between 4 and 5.
yeah,
Copy.
copy.
Oh, I'm good.
Oh, look at all those bubbles. Where are those?
That's where we are.
Copy.
By us or? Ah,
Are the fresh bubbles different colors? So some of those are historic and some of those are last night.
Oh, here's a different fish. Come out a little bit, video.
That's cool. Bubbles.
Yeah,
What is it? So
pilots, all the bubbles that you're seeing on the screen were mapped last night,
wow.
and the ones with the stronger plumes have been previously explored.
Okay.
So we're targeting this kind of in-between site between the ones that have been explored before to
Come a little tighter.
check out.
Okay. Cool. Thank you.
You're welcome.
Copy.
Oh, there's a...
Floaty.
Yeah, it's a... I can never say it. I'm horrible at the biology pronunciations. A Okeanos
Oh,
or
cute
something.
nest?
Something.
Right.
What's that?
Okeanos. That's, I believe, and these are like, they call them arrowhead worms.
All right, we'll let it float. Oh.
We're on the move here. I got you 5-3. How long was that move? Is it a... Copy. 10 times 4.
This is, reason number 104 why I didn't become a biologist.
1.3 tether lengths.
Ooh, big spoonworm. Those are so much fun to watch. Yeah, so Jim Masterson says the base of that little arrowhead worm that we saw, the ketognath, the keta is the bristles and the gnath is the jaws. So they have these really kind of jaws that are almost the size of or the diameter of their body.
Yeah, so your lower frequency is half the beam width. So if it was properly reading on the Sirius, that would be even better to have. Oh no, sorry, that would be. I guess it'd be better for both of them to be high frequency. Although the lower frequency has a 300 meter range, the higher one has a 100 meter.
Oh, we have a nice
Yeah.
floaty. I thought initially it was a lobate ctenophore, but it is not. It's a I think it's a larvaceous casing.
Same move coming up. On the way.
Yep. And Adam, while we are transitioning, could you talk a little bit more about, in the intro you were discussing that, we're at a depth where this should be within the methane stability, but yet we are seeing, at least in our multi-beam, we are seeing the bubbles. So we do have some gas bubbles, and why that is an interesting kind of dichotomy.
That was actually me.
Oh, that was you, Carolyn. Thank you. Sorry.
I'm sure Carolyn can provide a better answer than I could to that, so I'll let her take it away.
All right, great. Thank you.
Yeah, I mean, we're gas hydrates people. So, right. So the deal is that there's that methane in water, once you reach a certain pressure and temperature, so relatively high pressure and low temperatures under marine conditions, you're going to make the methane in water into an ice. It's called methane hydrate, and that occurs naturally in nature. It's typically below the sediments, and it can extend hundreds of meters into the sedimentary section, to the seafloor. So down on the Blake Ridge, for example, that zone where methane hydrate is the stable form of methane and water is hundreds of meters thick, although the concentration in the sediments is down to maybe 2-3% of the sediment has methane hydrate. So here we're at water depths where the pressure is about 13 megapascals, so it's about, or 14 megapascals, very deep water, and the flow temperature here, so the temperature here is about 3.8 degrees. We're well within the stability zone for methane hydrate, which means when methane combines with water, it should be methane hydrate. The strange thing, and what kind of provoked all of us back in 2012 when NOAA started talking to my agency and my project, the USGS Gas Hydrates Project, is that this is not methane hydrate here. We have free methane bubbles pouring out of the seafloor in various places at these profound water depths. So while this happens at some places and it's caused by certain conditions that can make it happen, it is a little strange. We would think that we would see methane hydrate trapping this methane gas instead of allowing the methane gas to escape. Now, it is true that once the methane hits the seawater in these locations, often the bubbles will form a hydrate shell around them, and that affects how buoyant the bubbles are. It also affects how much of the methane and how quickly the methane can come out of the bubbles and go into the seawater. So the hydrate picture is still here. If we do see methane bubbling out of the seafloor here on this dive today, we're likely nearby, if we're lucky, to see a rock overhang, and we'll see gas hydrate underneath of that, because there the methane is concentrating, and we'll see the hydrate actually forming beneath these ledges, which we often see as well. But again, most of the time the methane hydrate is in the sediments.
Okay, great. Thank you for that. And yeah, I hope we do get to see some of that overhang and some methane hydrate. That would be very cool. Perfect timing.
Nav, were you calling us?
I was just about to. Yeah.
Oh, okay.
Thank you, Bridge. We have traveled 300 meters total.
Thank you.
Yes, pilots, that move is complete. Would we like to keep a move on?
Oh, you go.
Copy. We can go, yeah, start that way, 330. I'll keep it at 40 for now. That's weird.
Looks like we have a little more bacterial mat here, and
On the way.
Yeah, just a partial is great. Thank you.
is that a little baby eel pout? Little bitty bitty. It is.
Yeah.
Oh no?
Maybe, yeah. It is very small, but
It is very small.
That is when they just started moving too, I guess.
oh, is that a spoonworm? Oh, yeah, good eye.
is.
It's a very long proboscis. So essentially this is the tongue of a polychaete worm, and it extends out to feed on particulate coming out of the water as well as on the sediment, and then it will retract that whole proboscis back into the hole that it's coming out of where the rest of the worm lives.
Nav confirms. Surprised he hasn't come back in yet.
Yeah, usually. Oh, there it goes. Nice. And thank you for the sound effects. Thank you, Levi.
Yeah, something like that.
Couple burrows.
Got tracking back, I guess.
Oh. What?
We got consistent tracking back, but that's
Offset quite a ways from what we were seeing earlier. Maybe they'll come home.
Casey, you're hot. Hot mic.
I don't know. That's why I ventured over here. It's got like a hole. It looks like it's rusty maybe or something like that.
So I'm not sure what's going on with this tracking here.
Come in a little bit.
Go ahead, watch one. Yeah, no. Yeah. Oh, don't worry about that. Just the background. Maybe local 1540, something like that. Got it. Depending on how far we make it, obviously. Yeah.
Yeah, seeing a bunch more of these mussel shells. And are you guys seeing bubbles on your radar? Oh, okay.
Go ahead. I don't think so at this time. We'll keep trying to diagnose. It'd be weird for that to start now. Okay, thanks.
Moved up to the higher rent district.
So, Carolyn or Adam, if you guys are on the line, when we've been exploring these areas, we sometimes see that these the plumes are turning on and off. Could you explain about how that could happen, or sort of what we know about these seeps being somewhat ephemeral?
This is Adam. I can try and answer that.
Yeah,
That's a good question. You know, one of the things that geologists are still trying to understand is exactly the nature of the plumbing system for gas migration beneath
I
the
am
seep
also
site.
sneaking in on it, so you know for your focus.
All evidence indicates that the gas is coming from production from microbes in relatively shallow sediments just beneath the seafloor. And so as that methane migrates through the pore space in the sediments and finds its way to the seafloor, it can take different pathways. Sometimes, as in this location, there are probably structural geology features like faults in the sediment that form pathways for that gas to follow. And so it's not fully understood, but I think a lot of us are under the impression that that methane hydrate Carolyn was talking about can form or disassociate in different locations within that sort of plumbing network underneath the seep fields, and that can turn on gas in one location or turn it off in another location.
Yeah, chimera back there or something.
Okay, thank you for that. That's one of the fun things about being a scientist. I think also one of the frustrating things, but one of the fun things is, you know, we learn more about something, and I feel like it just then opens up more questions as well. And trying to actually understand kind of that internal piping is really interesting.
So one of the things that we've liked to say over the years about the Okeanos Explorer is that we are not hypothesis testing, or we're not testing any specific questions, but we are generating them. And it's a hypothesis generating ship and mission here that we do, because so much of the deep sea is unknown and unexplored that the more time you spend down here, the more questions you walk away with every single time.
Yeah, absolutely. And you know, it'd be a fun activity to think about. This is our 100th crew, the 100th cruise, the 100th cruise expedition of the NOAA Okeanos Explorer, America's ship. And
let them go. Let me just
how many questions has it generated over those 100 expeditions?
You're absolutely right, Amy. In our 10th year of exploring the ocean, our 100th ocean exploration mission, there is so much that we have learned about the ocean in all the basins that we've worked in.
Take a look.
And we're back along the Atlantic coast for the first time in a couple years, this year and last year, after a couple years in the Pacific. And it really is quite amazing. Every time we go down here, we learn something completely new.
I'll reselect waypoint 5 here.
What do we have here? Chris, identify.
Yeah, we hadn't seen these all cruise, and then we saw one yesterday or the day before. And
yes.
these,
the mouth.
Yeah, exactly. Look at that, those teeth on that bathysaur.
The eyes are often like golden, aren't they?
Nailed it.
My very first deep sea expedition, we landed about 10 feet from one of these guys, and I could not look away because I was so enthralled with how different these look than anything I'd ever seen.
Yeah.
And how much just like a dinosaur.
These guys usually cooperate, but I won't land too close. Yeah, start coming in.
I would believe our current tracking. What do you think, Copilot?
Yeah. Judging by the relative is really good. I'm going to turn to starboard then.
Yeah, I think that's smart. We're headed that way anyway.
So we've seen these over the years in pinks and purples and blues, and this pretty silver gray is really nice as well.
Okay. Yeah. Let me line that up for you.
Looks like my heading should be 42.5. Try to get there.
Fighting to starboard, guys.
Oof. Look at all those little pokers.
It's just, has this big toothy grin, that's all.
I wonder what kind of prey they eat.
That's a good question.
Got any more? Okay.
They do cooperate really well. They just sit very still.
Because if they hold super still, you can't see them, of course.
Of course. Absolutely. This is, we are at 1,610 meters of water depth right now and 85 miles
do,
off the coast
Come out
of
partial.
Virginia. And
Lasers on it.
there is
Are they,
typically
catching the lasers
no
on it?
natural light down here. So yes, being nice and still on the seafloor means you don't get
Come out a little bit more so we can see those
seen.
lasers. Just turn them on. Levi.
Lasers coming on.
Thanks.
Oh, great. Thanks, guys.
Awesome.
Yeah,
I
so
thought
a
you were
couple
saying,
days
like,
ago, Ken
you were gonna turn
Sulak
them on?
had said about the bathysaurs that they
Copy.
kind of have this
Copy.
classic sit and wait ambush
Okay, we can kill
predator.
'em.
And
And
it will
then,
often nip off the tails of other large
use the
fish, and we
additional
have
asset.
seen a couple examples
extra
of some
lights.
of the, I think,
Yeah.
snappabranchids that have maybe had a little nip
We're
out
gonna
of their
turn on,
tail
high
fin.
beams
And
real
they
quick
eat a lot of
video.
midwater fishes
Yeah,
that come
fine.
down near the
Whoops, what's
substrate.
up?
So they
Okay.
sort of just sit
That would be
there
good for our
and
eyeballs.
then wait for something to be within range and
And we can turn
strike
on
very
the
quickly.
other guy.
Copy.
Bank one. You know what I'm saying?
Yeah.
Bank one, lower left.
Oh, and we're gonna take one more second with this.
Yep,
We're going to bring the lights on, Roland.
I'm following you.
Lights are on. 3, 2, 1.
It's on aft. Can we just switch it over? Check
Stand by.
image.
Ooh. Nice framing.
Nice.
Come a little bit, yeah. Bathysaur? No, what is this? Bathysaurus?
Bathysaur. Yeah.
Bathysaurus. Bathysaur. How do you remember that?
Because it,
Cool fish.
it looks like a dinosaur.
Oh.
Alright, that looks good. Moving on.
I'm going to bring the light off.
Thanks, video.
Okay, pilots, the plan is to head northeast from here. As you know, might see a little bit more slope.
Wait, where's 4?
We are currently over 4.
But wait, it's between 4 and 5 that we see stuff, right?
Correct.
Okay.
Well, that's the hope, yeah.
We're trusting this
The tracking?
tracking.
I think it's been consistent enough for now, yeah.
Okay.
It was consistently wrong over here for quite some time.
Okay.
But this makes sense with
the layback.
Layback and what we were seeing on our previous moves.
Copy.
I think we can do 30 meters. What do you think, pilot?
You guys good with 40 for the bearing?
Yep.
30 meters?
I'm lined up on 40. I got a clear view ahead.
Roger. Coming up.
On the lawn looking for bubbles. Copy.
Right there.
Okay. Aye, aye. Right on the,
Yeah, I'm guessing right here.
right on the crook of that. Okay.
Yeah, center. That's my guess.
We shall see. Yeah, I was gonna put a target right there so that we can make sure we know exactly what you said, so you can't change it.
Stand by one.
Right on the bump. This little.
Yep. Oh, that was it.
Yeah,
Down.
that
Down a
one.
little bit. Down. Oh, down.
That's what you said, right?
I heard him say that. Yeah, he's trying to change it now.
So we have
You can
another
control, click and drag and move. waypoints.
little
Okay.
bit of maybe some of the bacterial mat over
Great.
there on
Are you
the
gonna tell me
right.
where to put it?
Oh,
But
you were
we'll
really
keep
close.
moving.
On that line, a little bit lower. Yep. Oh, right there. Perfect. That's where it's going to be.
Copy.
All right, we got the ship going. Just starting to move here. Headed to waypoint 5.
Yeah, you'll see as we cross the 1,600 meter contour, you'll start to see a little bit more relief. Be advised.
Copy. I have some harder returns, but it's all right here, and it just looks like maybe just bumps in the sand.
Yeah.
But we'll keep an eye out.
Roger. And could you tell me what your Z bias is today, pilot?
I've settled somewhere around 25.1.
I would run
It's between
RPMs.
25 and 26. RPM
Not
28.
percentage. So your birds are doing 525 RPM.
So
Because the
when we
percentages aren't
look at the
necessarily bad.
multi-beam in these areas,
If you're doing
a lot of
mechanical-
times we
if you're doing
see
mechanical
what looks to be a
calculations.
very smooth surface, very flat, particularly where we are right now. The multi-beam said it was going to be pretty low slope, but we're seeing little tiny
525.
topographic highs. Why is that?
So our multi-beam system is
into a
it's a great system and a really fantastic tool, and has helped us learn a lot about the seafloor. But it is ship-based, and we are in
No
1,600 meters of water, and therefore we can't resolve these
rack
very small
caps.
features. And when we talk about that, it's typically a 25 meter of resolution, and so we really can't see anything smaller than that 25 meters, and that's typically in even more shallow water at these depths. I don't know the exact resolution, but we can't make out these kind of small dips and bumps and little valleys and burrow holes and things like that. You would need either some type of tow system. They have the multi-beams that you can actually tow behind small boats, or a side scan system to be able to really see the detail that we're seeing here in person.
Over here, see what's going
Part of
on.
the reason that exploring with submersibles and ROVs and, like you said, those other towed systems are really important. Oh, here we go.
Yep. Seeing a little bit coming into our view at the very top, looking very rocky. Maybe some mussels.
Maybe some bacteria.
Maybe some bacteria.
Oh. Roland's driving.
It's Adam. This is a really great view here as we come up on a carbonate rock outcrop. One of the things I'll point out is the rock you see here is formed in the sediment by microbes. So little tiny biological organisms actually produce these rocks that you're seeing here, and then they later get exposed to seafloor through erosion. And it's kind of an interesting relationship because you have a biological process creating geology in some sense here, but also this geology enables seafloor biology because it creates these hard rock outcrops that then organisms like corals and mussels can attach to. So it's a very intricate relationship at these seep sites between biology in the subsurface and geology in the organisms that live on the seafloor.
Yeah, that's a really great point to mention. And as we kind of passed over those and we're kind of heading up this slope here, we could see in that carbonate that there were a lot of little holes within that rock. And is that because of the bacteria, or is that because of the methane bubbles?
So that's a really good question. Sort of the nature of the rock appears that there are conduits through it, potentially where methane has moved through the rock and creates a sort of bucky or sort of Swiss cheese texture that you see in the rock. But actually, scientists are still working to understand exactly how these rocks, they know sort of geochemically how the rocks form, but sort of structurally how they form in the subsurface and what creates those unique textures.
Okay.
Not much.
We have a little squat lobster. It looks like it's inhabited one of those small holes of a piece of this carbonate.
Okay, that's clear.
Yep. I'll also point out that we don't have great data, but there's been a little bit of work done on how quickly this rock is formed by microbes in the subsurface. And the fastest rates that have ever been measured show that it grows about 5 centimeters every 1,000 years. So if you sort of imagine taking the D2's lasers and turning them sideways, for the rock to cover that distance, to grow that distance, would take 2,000 years. That kind of puts in perspective when you see these large outcrops that appear to be many meters tall, just how long it might have taken for those to grow and form at these sites.
Yeah, that's pretty amazing.
Holes, but I don't see bubbles yet.
And Carolyn had mentioned earlier some of the, published and unpublished data that has given some sort of dates of these carbonates. And I think I remember her saying something around several thousand years. And that would be when these were forming. So these seeps have been likely active for many thousands of years.
Only happening ever so often.
That's something that's so interesting.
Yes, that's right. They have some samples from the site that indicate, I think, up to 4,000 years. And there are some samples that have been published by Carolyn's group and Nancy Crowd at USGS farther north in the Atlantic Ocean that go back as far as, I believe, about 15,000 years.
Wow.
Wow. And Adam, would the seep need to have been active that entire time, or have had some sort of activity over that period?
Still gonna go look at it.
You can't say that they've been active the whole time. What you can say is that there was the seep activity is necessary for the rock to form. So what you can say is that there was seep activity at that location at that date. You can't necessarily say it's been continuous since then. But again, that gets a bit to the rates of carbonate rock growth. But you can certainly say that there was seepage active at that date, at that location.
I think we're ready for another one.
Great.
Partial.
And it doesn't necessarily mean that was the oldest seepage at that location. It doesn't mean it necessarily formed then, but it was known to be active at that time.
Right, exactly. Yeah, it's really difficult to use these as any type of chronology in the sense of, when did they turn on, when did they turn off, because especially as we've talked about is how much they actually do migrate and move where the methane is coming out.
Not sure why I'm getting pushed forward. Stand by.
That's right, and there are different scales of sort of turning on and off. So I've been on an Alvin dive where we've watched seeps turn on and turn off over the course of maybe 10 or 15 minutes. We also have repeat surveys by the Okeanos Explorer at Beach Canyon where they do their patch test for the sonar every year that show that the seeps are turning on and off over the course of, you revisit it sort of once a year, and you can see that at that interval, some are on and some are off over a number of years. So there's sort of appears to be a bit different scales of ephemerality. And certainly when we get into longer, multi-thousand years, that introduces things like changes in global sea level, which affect pressure and hydrate stability and might impact the ephemerality of these sites on those much longer time scales.
Yeah, thank you.
And we've been watching this pycnogonid, or sea spider, as it is walking across the seafloor.
Okay, Roland, I'm clear when you are.
Lasers.
Some lasers, yeah. On the same page. It's big.
And if there are folks on the
Thanks, video.
line, Casey and I are going to be out for an hour or so. We're actually going to be doing a webinar from the ship to the NOAA office in Silver Spring.
So should we do short
So
hops
if
through here
folks
so that we
want
can
to call in or chime
keep
in
or
and
just
talk
stop it
about
when we
what's
get
going
near
on,
something?
I
it
guess,
always makes it easier to have a conversation as opposed to be
let's
sitting
keep
here
it at
talking by
30, I think.
oneself. So I will be back about 1
I think
o'clock,
if we catch it early
and
enough, we can stop it.
Alexis
Still be
will
okay.
be here with you guys.
What do
Hopefully
you
you
think?
guys will
Maybe we could do
find some
22, I
actively
guess.
seeping sites. It looks like
I'm happy with
maybe we're
30s.
getting close. So
I'm already stretched out at waist.
Yeah, and I think in a little bit,
See what the dark red thing is
Shannon
up on
Hoy,
there?
our mapping lead with
Dark red
OER,
upper
will
left
be on
possible
as well,
rock or
so we
campus.
can have
I've been seeing a lot of
some more
debris
insight
here.
into
Could be a can or
this kind of
something.
hunting for bubbles situation. But we will be cruising along here on our cruise track
Okay.
and coming up
Coming a little
on
bit.
some of our targets where we saw a bit of active seepage last night.
What are you looking at? Oh, it's a shell. I was wrong.
Yeah, it looks like a mussel shell.
It is clear.
Okay, pilot's clear.
Bacteria mats, the little ones, I'm starting to see definite holes in the center of them.
Yeah, I've been seeing those as well. But I haven't seen any activity from those orifices.
Copy.
It's like D2s.
Yeah, bouncing around. Is that what you were going to say?
No, I was going to say a bearing and a distance from a certain target. 40 meters out. So that contour. Okay. On the move, going uphill towards waypoint 5.
So even these returns now, Jeff, like in your sonar, seem hotter than any of the other ones.
Yeah.
I guess there's a bunch of like rubble and maybe some substrate there.
Ooh, another sea spider on the bottom right. Just coming off. Yeah, I'm not sure. I think maybe the sediment's just gotten a little firmer, yeah.
Yeah.
Or I've also been switching between flying like 2 meters up looking for bubbles and flying half meter up or something. It's like
It seems like, yeah, that's true.
Dip on the left.
Oh, yes. Good eye, Roland. Doesn't seem like it has any polyps or anything, but we can still take a peek. Take a partial on the whip, just see if it has anything going on, rather than being some sort of stock.
Yeah, it looks like a stalk. Since we saw that Beluga earlier, it makes me wonder if maybe that's what this used to belong to, is a sea pen.
Wow.
Yeah, you can see a little bit of tissue on the stalk, but just at the top, it is. Looks like it's been clipped.
Okay.
Moves
That's
complete,
fair.
pilots. You want another one?
Yeah.
Yeah.
Yeah, I just have to make sure I avoid this.
Yeah, understood. Yeah, we'll be smart about it.
Tilt up, I can show you the distance.
Avoid that.
Tree.
Not seeing a lot.
Slightly right of center top is mussels.
Yeah, I see that. Okay.
Everything else around there.
Let's see. Anything closer than that to address first? Okay, whatever's over here.
So we started today's dive around 1,620 meters, and we are working up a pretty shallow slope, and we're currently at 1,603 meters.
Over and over.
Looks like we have something in the distance.
Yeah, another, like a little electrical panel or something. Definitely. Find some wires or something associated. Don't see anything light in the air, or in the water.
Agreed.
Might
Watch
just be a
late nav.
trash can.
Go ahead, Nav.
We
A little bit.
have traveled another 100 meters. That gives us 400 meters total.
Thank you.
Can go partial. Just check out what this is. It's upside down.
In something from South Carolina.
Tej.
In Tej. Service. Something service. Like plumbing service or something? What is that bottom word?
Stand by one.
And again? What's the bottom left corner say? Utility service.
Quality.
Oh, quality. Alright, fine. That's probably right.
Woodruff, South Carolina.
Enhance. Google. It's definitely a cable associated.
I'm thinking transformer.
Yeah.
Looks like a good anchor. You're just up to my port.
Copy.
We're on the move.
Alright.
We've
At
seen
80 degrees.
an interesting amount of
Saw some shells out this way, so we'll push
human
there.
debris, but we are actively looking for cold
This-
methane seeps or seep sites. Oh
These-
yeah, and
these
we
are in
have
reach, so we're gonna peek out this way and see what we got.
looks like some shell debris, which is generally indicative of live mussels in the area.
It's steep, so I don't have a sonar returns for a little ways, but we'll follow the shells. Hopefully they lead us.
Just off to my port side.
Copy. Port side. Coming in. To view. Ah. Oh, food service.
Another picnic donut on the left.
Yeah,
on the left.
another large pycnogonid.
Sorry, just a little behind track here. So
No, you're fine, pilot. Sorry.
catch up.
Just
No, you're good.
making comments.
Co-pilot, permission to adjust your sonar.
Yeah, go for it.
Got distracted by the food service equipment. Move along.
Yep. You're flying about the same height, right? Or altitude.
Yeah. Ooh, what's this?
It's interesting.
Dead ahead D2.
Yeah.
15 meters out.
It's another spoonworm proboscis on the bottom.
Yeah.
And if you're on shore watching, we are currently underway with dive 19 of Windows to the Deep 2019. We've had an opportunity to explore a number of different habitats off of the southeast U.S. as well as now in more of the mid-Atlantic region.
Much brighter
And
patch
we are
at the top of
ending
the screen.
this cruise with an
Yeah, copy
exciting methane seep
like similar
exploration
stuff.
dive.
Can we turn to keep you in view?
Yeah, I think we're gonna head up this direction. Or we should take a peek out to the east here just to confirm there's absolutely nothing over there.
Yeah, agreed.
Yeah,
Copy.
Just confirm.
just confirm there's no targets over here. We'll just take a peek real quick before we move on. So this is the track.
It's good to be thorough in these areas.
Agreed. Yes. Right up there. Yeah, there seems to be
Yeah.
some sonar returns.
It's right here.
Yeah.
Yeah, don't see anything.
Oh yeah, there's some more, looks harder substrate up there.
Now, can you employ the control drag for us, please?
Yeah, I'll try that new feature.
I don't see any bubbles yet. Have you guys?
No bubbles. I see some mat and some shells here on the left.
Yeah.
Thank you, Bridge.
If we can do a zoom on the patch of mussels.
I mean, a partial zoom fly through of this
Yeah.
area.
Come on in. Looking for bubbles.
Could probably just rename that target.
Another, it looks like we have another patch of living Bathymodiolus childresi, a chemosynthetic mussel.
It's a nice view from Sirius.
Yeah, we're right at that target now.
This is Carolyn. I just want to say again, as I said the other day on the Seep dive, that we kind of get complacent when we see these wonderful photogenic scenes with these mussels and other chemosynthetic organisms and bacterial mats. But really, this is pretty amazing. Okay, so 5 years ago, we were just seeing, or 6 years ago, we were just seeing the first of these along this margin. And before that, didn't even know that they existed. And always extending the habitat to a wider area is very exciting. So we didn't know this patch existed this morning, and now we know it exists, and it extends the size of the area near these Norfolk seeps that has chemosynthetic organisms.
Yeah, thanks, Carolyn. That's definitely true. Some of us that kind of spend a lot of time with eyes on the seafloor, we forget just how really extraordinary these sites can be, and how all of this, when we're seeing it on screen, we're all seeing it for the first time that anyone has ever seen this part of the seafloor. And I think, like talking about how we people just recently started kind of starting to understand the seep communities in the Atlantic. The first real chemosynthetic communities in the ocean were only discovered in the 1970s. So when you think about how much is still left to learn about all the different various parts of the ocean, and how really recently there's a pretty large mussel on the bottom of middle. Can we just get a close look at that with lasers on? Yeah, so there's and I'm
couple shrimp
definitely not a chemosynthetic mussel expert by any means, but there's another species of Bathymodiolus at some of the other seep sites on the margin called Bathymodiolus heckeri, and they're known to be much larger. So if we have any of our chemosynthetic community biologists on the line or in the chat, always feel free to jump in. This could be just a really large Childresi, but I'd love other opinions as well. Oh, good eye. So a lot of snails on these mussels, which we haven't been seeing throughout the rest of this area.
For all the extra lights.
But we do often see snails on other chemosynthetic communities.
Yeah.
Will give us more red.
Hi, this is Tara with Stockton University.
Hi, Tara.
Hello. So I can't really talk about the differences between heckeri versus Childresi, but I do want to mention that these really interesting, charismatic megafauna are beautiful to look at, but what's really actually doing all the work is the bacteria, and within these mussels, you have bacteria that use these chemicals. Seep, you're going to find anatrophic bacteria that the methane that comes out. Places like hydrothermal vents, you're going to find sulfur oxidizing chemoaerobics. And while you can't actually see them, well, except for the mats, they really are kind of what allows this ecosystem to thrive.
Yeah, that's a great point, Tara, and thank you for calling in. I am definitely not a microbiologist, but you make a really good point that we often focus in on the things we can see, but a lot of, especially in these communities, what's doing the work, like you said, are the microorganisms within the sediment and making up all of those bacteria mats as well.
Yeah, but it's harder to actually visualize them when you're actually broadcasting. So, I'm just as happy for these environments that allow us to actually get a sense of what's there.
I said a really small bubble. We have really small.
Hi, Alexis.
Hi, is this Cheryl?
Cheryl. Yeah, I just wanted to say I hope that is a Bathymodiolus heckeri. My lab was involved in working on the mussels, characterizing the mussels from this area in the Mid-Atlantic Canyons project, and we saw mostly Bathymodiolus childresi based on DNA sequences, but there was one heckeri, and it's actually the depth that this is at was shallower than we would expect to find heckeri, but it's exciting that there might be more of them. It was only one out of something like 100 mussels that we sequenced, so that's really exciting.
Thanks, Cheryl. That is really exciting, and we I think later on in the dive we will attempt to collect a mussel or two as we're going through, but we're probably going to do that just a little bit later, and if we happen to find one that is larger and something that we can get with the ROV, we'll definitely go for one of those.
Yeah, great. It'd be nice to get some smaller ones as well, and for the comparison.
Yeah, absolutely.
This is so exciting. This is really great.
Good. I'm glad everybody's on today watching our last dive, which has been going really well so far.
It sure has. I can't believe it's the last dive already, but it's been such a great expedition.
Yeah, it's a nice addition to the expedition you were on last year out here in 2018, where we got to characterize a number of other sites.
Yep. It's amazing what's off our coasts right here that we get to see for the first time and share with the world this way.
Absolutely. Our pilots are going to do a quick pilot change so they can, eat some food, which is important. And I have sitting here with me from the NOAA OER team is our mapping lead.
Hello, everybody. I'm Shannon Hoy from NOAA's Office of Ocean Exploration and Research, and I'm the mapping lead, sitting in for Amy for a bit while she's doing a seminar. She's doing a seminar. So I'm just here to keep Alexis company, and if you have any mapping related questions, I can answer those, or just join the ride with you guys.
Yeah, we have a great team out here with us. You hear Amy and I on the OKEX line a lot, and you hear our pilots and our video team, but we also have a lot of people that work behind the scenes, essentially, like Shannon, who spends, all day helping us make products about the seafloor that we're exploring, and then her mapping team works all night to create those maps and really give us that context for where we are within this mid-Atlantic region.
So I'm not sure if you guys got the update. We're headed to waypoint 5, but we're going to try to stop Cirrus a little bit shy of it and then have D2 go out to it. That way we can kind of follow the contour over. They don't want us to come back down.
Copy.
Yeah. Other than that, bail out southwest. So it's just as a heads up. And it's, if we go by Cirrus, it's about 40 meters to that waypoint. Probably cut it a little bit short, maybe 25 to 30. Put us kind of in that. Yeah, we could probably go 30 and then see where we are. And they've been doing a bearing of 40 degrees. Looks like what y'all are about set up for, right? Okay. So you ready to?
Yes.
Okay. We'll do that. Bridge nav. Yeah, you ready for a move? Okay, distance of 30 meters, 30, bearing of 040 at a speed of 0.2 knots. Roger that, thank you. Yeah, it might put us just a little bit shy, but
take a quick tide of a...
All right, everybody. It looks like we have a mapping question coming into us, asking about a Z bias, for example. So I think what this is referring to is potential error or potential places where a depth bias could come into our mapping operations. And I think, generally speaking, we're out here using a ship that right now is 1,600 meters above where we are. And so that means that resolution we're able to get on the seafloor is not as dense as maybe in shallower maps that you're used to. So generally our maps are about, 25 meters, 15 meters resolution, and that's going to be an average grid of the soundings that are within that box, which sometimes can be 2, sometimes can be 4. To make a better, I guess, hypothesis for or average for that 25-meter space. In terms of depth bias with our sonars, it's actually quite good. I think it's about 0.1% of the depth or so. And that obviously changes depending on what sonars you're using. Depth bias can also come into, they might have been speaking about, vertical exaggeration, how we're displaying the data on the screen, to convey it. There's a great book that's like How to Lie with Maps, and maps are always a representation of the truth, and it's up to the cartographer and the map maker to try to display the most what they think is the truth, or to highlight what they think is useful for someone interpreting the map. So that is like one of the big, with great power comes great responsibility, is how do you display this information, this real information in a hypothesized or estimated world. So we try our best here to get the correct position and to convey the correct, exaggeration of the bathymetric features to both aid scientific interpretation as well as ROV operation. So I hope that answers the question that was asked, but if not, pose it again in the chat, and we can talk about it more.
Mm-hmm. Thanks, Shannon. And we have another, we have a pretty large carbonate outcropping here. And like Adam had talked about earlier, these really large areas of rock are created by the bacteria that Tara was talking about as well. And this can take a really long time, and these are pretty significant rock features.
Copy.
If we could have lasers on.
Lasers on.
Thank you. So those lasers in the center are 10 centimeters apart. So again, these slabs are quite significant. Yeah, right on the top of that rock. Sorry, go ahead, Carolyn.
Go ahead, in video.
Oh, okay. Yes, Carolyn. I just wanted to reiterate something I said earlier in the call. We have been collaborating with British Geological Survey, specifically Diana Say and Dan Condon, who are experts in uranium-thorium dating of these complicated orthogenic carbonates. And the ones here are being dated about 3,000 to 5,000 years old. Again, that only means that methane was being emitted around that time. It doesn't mean that's when the Seep started. It doesn't mean it's been continuous since then. It's just that the dates so far seem to be coming down in that range. An early date was published in Nancy Crowdy's ECSL paper in 2016 from a NOP dive in which they collected samples.
Great. Thank you, Carolyn.
Video's clear.
Okay, come on out.
Another pycnogonid. We've seen at least 3 or 4.
Yeah, good eye video. We have another pycnogonid down there. And Bob Carney made a good point, and you could see it when we were close in on that fish. There's a lot of what looks like fossil shells in these carbonates. So the total kind of aggregation here is likely both the shell and the orthogenic carbonate cemented together. Yeah, this is really great to see.
Ship should be just
The
about finishing
previous
that
work in
move.
this area had documented a
Looks like it
pretty
might take you just a
vast
minute to swing in.
cold seep area with large mussel beds, and really what we're able to do today by surveying this track is that we're able to continue to add to that information and continue to see just how large this area might be.
Yep, and something I always think that is fascinating is that, from what we can see, that there's not a massive abundance yet of bubbles, and the capabilities of the technology and the scattering of that bubble, that contrast between that air and that water, our sonars are able to pick these up from 1,600 meters above them, and it's quite always an impressive feat of technology and physics to just even understand how that's possible, that they can maybe find just a few bubbles going through the water column. It's always fun to then get down here on the seafloor and at least be like, oh yeah, absolutely, you can see the evidence of maybe where these might have originated from and things like that. So, always impressive what, humans can create and use physics to their will,
Yeah. And we saw earlier, we were on a close-up, and it was a very small bubble that came out, and that's kind of what Shannon's talking about too, is that we can see what we're calling bubble plumes in the water column data, but those can be generated by very small bubbles seeping from the seafloor that are still detectable by those sonar waves.
Let's do a partial here.
Yeah, another dense community of mussels here, and at the top, all those little white dots, when we've zoomed in earlier, we've seen small snails that are on the surface of the mussels as well.
There's a stalk right. It's got a lot of that fuzz on it.
Hey, come on out.
So cool to see these communities. Usually I'm in there still making maps or, processing data or something, so I can turn around when everybody starts gasping, and see things, but it's fun to be in here real time and see as they come through.
Yeah, it looks like it keeps going
Starkey,
to
follow
the
up
northwest.
On Shannon's point a little bit about the technology. What is also really amazing is the ship's sonar images the bubble plumes coming out in this location as they did overnight on the Okeanos Explorer. And some of those plumes are almost 1,000 meters tall, which in sort of more practical terms, you could imagine the Empire State Building stacked on itself 3 times. That's how high these plumes are off the seafloor. That only gets them about 2/3 of the way towards the ocean surface. That kind of gives you a sense of how deep it is here and how large these features are in terms of what we're detecting with the sonar to find these seep sites.
You can come in tight.
Yeah, I just wanted to get a look at some of this area where it looked like there was really, really dense bacteria, and there is, and they're still coating a lot of these live but also dead mussel shells. It's just really crazy to think about that this is a bunch of very, very tiny microorganisms all making up this white fuzzy mat, and what they're able to do is process chemicals for their energy versus, which is why we call it chemosynthesis versus photosynthesis, where you're using light to create energy like most of what we're used to on land. And it's just such a different process, and something that there's still so much research going into to understand and even just identify the bacteria. Not all of the chemosynthetic bacteria has even been able to be identified or studied.
So are you dropping waypoints on some of these?
So right here, that's the heavy one. Yeah, there wasn't any on here, but I'll get it noted down. Watch leader, you calling nav? I don't hear you. Yes, I've got you. Well, from here, gives us a little over 3 hours. So, yeah.
No, go for it. Yeah, you can just let me know what you're doing. You don't have to ask permission. Just be like, all right, I'm following you to the left. And if I don't like it, I'll let you know not to do it. So.
And we can see the mussels really growing on the side of that exposed scarp feature right there. There seems to be some of these kind of like nooks and crannies that have formed over time
20 meters,
that we saw earlier. The first kind of area of mussels that we approached were in like in a valley, and these ones there seems to be a high concentration in those areas where there's
about the
some vertical relief.
About 20 meters, and then D2 could push out to waypoint 5. Good with it? Okay. We'll get that in. Good to go?
Yeah, we're good.
Okay. Bridge nav. Ready for a move. Distance 20 meters, 20, at a bearing of 040 at a speed of 0.2 knots. Roger that.
Can you come in a little bit on the map?
Yeah.
Thanks.
We'll just leave 6 in there. Yeah, that's a little better. Like I said, I think that'll put you in a good distance to be able to reach out.
Well, I can say every time we do a Seep dive and do the survey over it, then, there's not too much exciting, during our overnights or when I come on at 4 watching the multi-beam screen and stuff like that. So anytime we're doing the Seep searching and stuff and you see those big plumes, going through both the multi-beam and the EKs, it's quite an exciting time for me and my, watch leads at 3 a.m. So we're always looking for more Seeps as it breaks up a little bit of, not the monotony, I would say, of bathymetric mapping, but, changes it up just a bit.
Yeah, it's cool to come in and see in the way you can see the plumes in the water column data as it's being collected, and then Shannon and her team go back and can post-process that so that we can actually overlay those plumes onto the maps that she creates. I was up nice and early this morning with Shannon around 4 a.m. to take a look at some of this data before we had our dive today. So we've been quite invested in these Seep, kind of the whole process of the Seep exploring. It's new for me. I'm more of a deep sea coral person at the moment, but who knows what I could get into in the future.
You can ask the scientists if you want the correct answer, or I can make
and this
something
is Adam Starkey. I can echo a little bit of what Shannon said. In 2012, I had her position on the ship as the mapping lead for the Okeanos Explorer team, and We were at this exact location in November of 2012 conducting bathymetric surveys. It was not an ROV cruise, just a mapping cruise, collecting bathymetric surveys. And this was the exact location that we first imaged on the multi-beam sonar, a plume on the North Atlantic margin. And so that was, as Shannon said, sometimes making maps of the seafloor is amazing. It is technologically. It isn't as exciting for folks at the ROV dives, but I remember being on that cruise and the excitement went through the ship when we found those first plumes and realizing it was really a major discovery and kind of figuring out if we could indeed find more, which we did on that cruise. And then
left edge of that
it's been amazing, all the follow-up work on it. But that is some of the most exciting parts of the mapping work is when you get to see these bubble plumes coming up through the water column and identify them with the sonar system.
Yeah, I totally agree. And one of my main watch leads out here is Kevin Jerem, who actually worked on bubbles and EK, and he was with the Multi-Beam Advisory Committee as well. So it's always fun because it's at the end of his watch too. So he's done 10 hours or so before that, and he's the overnight one. So to come in and wake up, and he's a bit, I don't want to say giddy, but maybe giddy every time there's these massive plumes coming up. So it's fun to see, and especially towards the end of a long cruise, just as morale, it makes morale go up and everybody's happy. Bridge is happy to watch as these plumes go through, as they can see the live, as they're driving the lines to actually do these surveys, they're watching through as they come. So it's really a morale booster towards the end. And, on the mapping side, we love it.
Can we just take a look at that cord-like thing down below?
Go ahead, Dave.
Sorry, Shannon,
No worries.
Just trying to keep an eye out for some different
track it off
looking things.
Watch lead nav.
Go ahead, Nav.
Just letting you know, we've gone another 100 meters, D2 has, at 500-meter distance.
Great, thank you.
Yep.
Is that monofilament?
Okay, thank you.
I don't think so.
I don't know.
So it looks similar to the tube that was up there.
Oh, some zoanthids probably growing right there. That's interesting. Wow, this is very long. Oh, is this just like a cord?
I think this is
It's right there.
fishing line.
Oh, okay.
I'm guessing.
I think so too. It's like it's just been completely covered in bacteria and...
Video's clear.
That's good, thank you.
Out. Just gonna scoot over here for a second, John. Let me know if I go too far.
Could we get a snap on this fish?
Hey, come on in.
I wonder if we get front lights. This guy's very dark complexion.
Sure, go ahead.
Not sure if he's low enough, but
He's very low.
Good.
Tilted down 26 degrees.
There we go. Thanks.
Yep. Kill the lights.
Another fish straight forward.
Wow,
Then
just
the
look
groove
at
on
the
the right.
features.
Wow.
Yeah, I was going to say we're probably close enough, huh?
Yeah, and that's an interesting thing to point out as well is, though we have these, we've imaged all the bubbles that are coming up, maybe not all, but the bubbles that are coming up, and also the bathymetry, but, things like this are
Right
a bit
off your
small for
port
our
side
sonar to
pilot,
see.
just-
Yeah.
So,
you can see.
another fascinating thing is, looking at the bathymetric grid that we have in
I know.
comparison to what we're seeing real time.
Got stuff here. So.
And the information that you would get by having like either not a more high resolution technique, like putting something closer to the seafloor and flying it around, so that we could see all of these mounds, these more locally
So
high
if you're
topography.
looking at that right now, if we move towards waypoint 6, is that
Yeah,
going to
that's
be in
one
the
thing.
way of Sirius?
Is what going to be in the way of Sirius?
Those
It's
rocks.
always
That's
interesting
not a
when
problem.
you
Okay.
look at the
No
bathymetry before coming down and you
I wasn't
have an
sure,
idea of
just-
what you might
Sirius
encounter,
is
but those grids are
16
about
meters
25
above bottom.
meters by
Okay.
25 meters,
So it's
so
plenty.
we
Yeah.
generally, we come down and then there's this really
I
intricate
just know you don't
topography
want to
that
go
we kind of get to figure out as we
downhill
go through the
either.
dive.
It's going
And like
downhill.
Shannon said, there are ways
It's a
of
combination
creating
of factors. It's not just Sirius.
higher resolution maps. It's just
it's harder for us to get good
requires
video.
a bit
It's
more
harder for us
legwork
to
in the water.
navigate.
Yeah.
It's,
Yeah, a bit different
There's a lot of
tools, I'd
different
say.
things.
Yeah.
Okay.
So.
This is video, and I just
This
want
is
to
Adam.
jump
I'll
in
mention
on
that
the.
on a cruise that Amy and I were on together, we used an autonomous underwater vehicle in 2016 at one of the Seep sites that the Okeanos Explorer discovered to make very high-resolution maps of the bottom. The autonomous underwater vehicles are robotic submarines that can fly right down over the sea floor with the same type of multi-beam mapping system as a ship has and create very, very detailed maps, which are great for some of the exploration work that is ongoing in many of these sites.
So this is a pretty large mussel. Can we have lasers on when you have a chance? Oh yeah, so this is at least 20 meters. I'm sorry, 20 centimeters. I'm sorry, 20 centimeters.
I was like, we could almost see that in the multi-beam.
Yeah. Does this look like it's alive if we come
out
around?
partial video.
I don't think it's alive from
Okay.
my view. Not the big one.
Yeah, you're approaching waypoint 5 now.
All right, come on in video.
Yeah, this does not look like it is alive, but this does look like a Bathymodiolus heckeri shell. So a bit more evidence is what Cheryl was talking about earlier. They, in the past work doing the genetic analysis on these mussels, all
Right,
but
coming
one
up.
that they sequenced were Bathymodiolus childresi, and she found one heckeri in the area, and so we're kind of keeping an eye out for those larger mussels. We'd like to make one of those collections today if we can, but that one looked to be no longer alive. Even though it would have been the perfect spot to collect if it was alive.
This is Roland. I just want to jump on the Science Channel to make a comment. Been with the program for 10 years, and I've seen this ship and the mapping team really refine the science of being able to locate these seeps and methane hydrates and this type of stuff with the ship's sonars. So it's been really interesting to see that progress from the early days, and now that that has really moved the science very far forward.
Thank you, Roland. It's exciting to be a part
So
of
this
it
is
now.
waypoint 5.
Yes.
And see how far we come. I was an explorer in training on here actually 9 years ago now. So it's fun to be back as a mapping lead and be a part of that science.
Yeah, so the Okeanos has been in operation for 10 years now, and like Roland and Shannon just said, both of them have been involved
You wanna look around here just a little bit more,
for the
then-
life of the ship, and they've both, sorry.
Yeah. Okay. Watch lead nav.
Go ahead, Nav.
Yeah, just let you know, D2's right now looking out over the waypoint 5. So just kind of curious if you want to try to go up a little bit more or go ahead and move over to waypoint 6.
Yeah, so I think it would be best just to go on to waypoint 6.
Okay, receive.
So we are going to head...
So you want to take a... It looks like from Ciro's about 110.
Yeah, so we've been in this area where we've seen a good amount of live mussels and these larger outcrops. Our next waypoint that we are planning to investigate is essentially due west, where there's another grouping of bubble plumes that Shannon had mapped overnight. So we're going to just continue on that way as we
bring it down,
explore this extension of this Seep site.
Bring it down just a little bit, maybe. Then. So, what were you talking about as far as direction? Yeah. 110 from Cirrus.
That's fine with me.
Okay.
So the bearing on the move is still 110, Mark.
Oh. There we go. Disable. You had those that outcrop of rocks and the bacteria mats that you were looking at a little while ago out there, just south of you, well, southwest of you. So,
yep,
ready for it? Okay. Bridge nav. Yeah, you ready for a move? Okay, distance 30 meters, 30. Sorry, bearing 110, 110 at a speed of 0.2 knots. Roger that, thank you. Okay, ship will be moving.
Big fish just swam off right screen.
I think we've seen this hake a couple times today.
It's a hake?
Yeah.
Just come on in. So what's the bailout? Southeast?
Southwest. Bailout
Southwest.
southwest.
Laser's clear.
I'll zoom out. You can see they changed it. It was southeast earlier, but
Southwest, okay.
southwest. Yep.
Right, it's coming out.
Bring the lasers back on if you want. So Wisp down there next to that anemone.
Yeah, there's an anemone down there.
I like having a biologist sit next to me because I can just point at the screen and she'll start answering. Though I have an undergraduate in biology,
Yeah.
I think, that was quite a ways ago. So it's like almost sitting next to a Wikipedia or something. I'm like,
That
what is
not
this?
true. But luckily, we have a number of scientists in our chat today who have always been helping throughout this expedition and the ones of the past. It's interesting to see this side of the feature where we're not seeing the mussels either, versus when we approached how dense those mussels were, even on the carbonate.
Another. Is it
Yeah.
a fly trap?
Yeah, I think so.
It just makes me want to get my hands on some high resolution AUVs and synthetic aperture sonar. Do
Yeah.
this whole thing.
Absolutely.
It's a really impressive amount of opogenic carbonate, and it's been, you can see that it's been probably uplifted a little bit or undermined or something and deformed, and it's rubble and a lot going on here in this sort of little canyon that we're in. These can be pretty violent environments with the current.
Yeah, I would be so curious what is in this little cave undercut section of this carbonate.
Let's get the fog lights on. Go ahead and roll.
Should be completing that move.
It's like a urchin under there. We have a lot of dead Bathymodiolus shells in there. And it really is interesting, the close-ups on the carbonate, to see just how embedded the shells are within that matrix as well, making up a decent amount of
received, thanks.
that structure.
Copy. We can put another move in.
Yeah, I was going to ask you,
Yeah,
do
and
you
we are
want to
moving west, which
stay
is
along
at a
that
little bit of a downslope, so it's
slope?
slightly
In
different
other words,
maneuvering
take
by our
maybe a
RV
little bit
team
more
to
of
traverse this move
say 100?
Safely.
What's the bearing to the
now.
waypoint? 110?
The bearing is 110.
Yeah, you can
yes.
just keep doing 110.
Just stay there?
Yep.
Okay. Okay. 30 meters, you good with that?
Sure.
Okay. Bridge now.
Is that a viper fish?
Yeah, ready for another move. 30 meters, 30,
Nope.
bearing 110 at a speed of 0.2. Roger that. Thank you.
You want to snap to that, or are we headed to it?
Another
We're heading that way.
chimera in the distance.
Sorry.
We've seen a number of this type of chimera today, and Shannon just whispered in my ear about how our first dive was also accompanied by chimeras. So nice little bookends
Go
there
in.
for this expedition. Oh, it has a parasite, it looks like.
That.
A couple more minutes on that move.
We're seeing more of these mussel shells potentially coming from upslope, but we are headed west to take a look at these plumes that we saw actively seeping last night. We haven't been able to detect much of the bubbles down here on this dive, but it'll be interesting to see if we find them at this next area that we're potentially anticipating them. There's
Right, and this is Carolyn, and I'll just say something I've said on these other Seep dives, that just because we can see them in the water column and C is in quotes there with the sonar, detect them because of the acoustic impedance contrast between the bubble and the water, doesn't mean they're easy to find at the seafloor. And you can search all day sometimes and not find the actual seepage point, even though the bubbles are, in fact, coming out of the seafloor. So it's not a big deal if we don't see the bubbles, but it's always cooler if we do.
For that target. Okay.
Looks like some sort of cartilaginous skate or array. I don't know how to tell the difference, even though I should have been listening when you guys explained it 14 dives ago.
But yeah, what Carolyn just said is definitely
Pilot, you're good with that.
all correct, and thank you.
Putting in another move, same
see the plumes in the water, but it doesn't mean we'll find those exact seepage sites on the floor. This looks like a ray. We saw one a bit earlier that has a similar or possibly the same type of ridging on its
Yeah, we're going to put in
back.
another move. 30 meters, 30, bearing 110 at a speed of 0.2
jellyfish.
Yeah, I think the little red thing, if we could zoom in on that. Looks like a benthic ctenophore. So these attach and they stay, actually, they don't spend the majority of their life up in the water column, but they are attached like this to some type of substrate. We did collect a benthic ctenophore earlier in the cruise. A straw, possibly, next to this ray. Or skate, sorry.
Yeah, I was going to say, actually, prior to the Okeanos, I mainly focused on, bathymetry, not actually imaging the water column, though I'd collected it before, but never really was too involved with the process. So it's been fun the last two cruises being out here and learning a lot more about our EKs and their capability and, the applications such as this for these sonars that we have has been a great thing to add to my wheelhouse, and I'm really enjoying, imaging the water column as well as the seafloor.
Yeah, I'm glad for you too, Shannon. It's fun as I've been out here. I don't have a lot of experience with mapping at all, other than using the maps to choose dive locations, but waking up some of the mornings early and working with Shannon as she's processing the data has really inspired me to come out maybe on another cruise and really learn how to do the actual mapping myself. I'm more of a biologist, but I think that kind of having a more rounded understanding of how we do this type of exploration is something I'm really interested in gaining as well.
Yeah, absolutely. I find the, geospatial context to support science is always helpful and good to know. It's something that I really enjoy.
And I should emphasize, of course, that these EK instruments were originally designed as fisheries sonars, and so they're really good at picking up bioscatters and fish with bladders and things like that. That's what their original use was for. So in fact, people like me, geophysicists who collect large amounts of these data, we're just really looking for people with biology skills to look at these data and try to understand also the biological aspects of what we're imaging. We just collect the data and put them in an archive. We don't really do anything with anything except the methane plume data. So the more the merrier as far as many of us are concerned.
Yeah, that's great. Thanks, Carolyn. And I think that's also a lot of the work that the Okeanos is getting into with the midwater exploration as well. And Shannon can talk a bit about how they've started to use that EK data during the midwater
Tripod
transects.
fish upper left.
Yeah, absolutely. We actually have a hauling scholar working with our Adrian Copeland, who was with us at NOAA OER, and the other midwater team, and he's actually looking at using the EK data to, I think, look at avoidance behavior, so trying to pair what we're seeing in the ROV imagery as well as with what we're seeing in the EK acoustics. Trying to maybe ground truth what we're seeing as well as identify habits, especially as the ROV is ascending and descending and transiting through the deep scattering layer and things like that. So that's on our radar. It's an interesting thing technologically to figure out as well, because obviously multiple sonars will interfere with each other. So when we are doing ROV dives, we are using the USBL to get the position of the ROV, as well as our ADCPs to monitor the current. So trying to find that balance between operational sonars that we need, such as the ADCPs and the USBL, but also collecting good data with the EK that can be processed and utilized by the scientists ashore is a balance we're trying to figure out while we're on this expedition, and see how we can improve that going forward.
Yeah, we have something swimming in the water column here.
Go ahead.
Yeah, possibly. Yeah, it looks like a polychaete, a quite substantial polychaete.
Yeah.
So a worm.
Yeah, that is.
Curious how it. Did
Bridge
we see
nav
it come
received.
off of the seafloor, pilot,
See
or
its
did we
tip.
just encounter it when it was already swimming?
I think we just saw it when it was swimming.
Okay.
Go ahead in.
Yeah, it's definitely a
Ship is
polychaete.
stabilizing.
It's really interesting.
We're stopped.
Don't know how it got up into the water column.
Let's kick on the extra lights.
Interesting thinking about what's below what we can see. That's actively living in the, is it epifauna?
Meofauna.
Meofauna? Okay. Yeah, something this large that, there might be multiple, living just beyond what we're visualizing.
Absolutely. This is quite a vibrant one.
Video's clear.
We kill the lights.
Watch lead nav.
Go ahead, Nav.
Yeah, update you. We moved another 100 meters with D2 at the 600 meter distance.
Thank you.
Yeah, I was going to ask y'all if you were ready. Okay.
There's all these mounds now on the seafloor.
Same move as last time, right? Just want to confirm. Okay. Bridge nav.
Have we been seeing these mounds previously?
Yeah, ready for another move?
Yeah, we've seen some.
Distance 30
the
meters,
topography is
30,
just a little bit
bearing
hilly.
of 110.
These large
speed
burrows.
of 0.2 knots.
We've seen a couple of, but not much. That's actually in them, or that we've been able to see.
Roger that. Thank you.
Copy.
That spoonworm?
Yeah, they have that long proboscis that they put out onto the sediment or the substrate and then pull it back in whenever. That we've noticed when D2 is not even very close, they'll start to retract it. So quite sensitive to their surroundings.
Yeah, with this move, D2 ought to be able to reach out to the next waypoint, but probably could get another small move and be right over it.
Who stirred up all that?
Wasn't us.
Is it coming from that?
So it looks like we're nearly at the waypoint with that other potential plume that we imaged overnight.
And there's, I don't know what
come on
that
in.
is.
Could this be a different type of plume?
Let's come in tight.
Yeah, come in to the
Upper
one
right?
that's really, yeah. Well,
Oh,
Is it
wow.
all
Something bubbling
animals?
up.
that's what I am yeah. They seem like small little burrows.
Drifting away.
Yeah, it's come out, come back in.
It's quite a round mound. And yeah, something to the right is interesting too. If we have any biologists or geologists
Right,
that are
come
with
on in.
us that have an idea of what is creating these little holes, and then there seems to be like a small stream of sediment coming out of the holes.
I'm not gonna see anything on the manip cam. All right, well, let's come out then, because no one else is seeing this.
Interesting that they're all in this one spot.
Right.
So, this is Carolyn. I'm not a biologist, obviously. All I can say is those were streaming down, right? So they were denser than the water.
Come on in. There's a crab rolling.
This looks like crab remains.
All right, come on out.
Sorry, Carolyn, can you repeat what you said?
I said when I saw those, it looked like those clouds were going down. They weren't going up, right?
Right,
they
correct.
were denser than water.
Come back in.
The surrounding seawater.
Right, so they're not rising up. They are moving. The cloud is moving with the current. And yeah, like
Can we see what it looks like with the extra lights?
Sure.
So it does have the look right there, what you're seeing with it coming out.
Doesn't tell.
I know we've seen on other dives, we've seen, so someone just wrote in the chat as well. It looks like fluid coming out, but it's fluid that's clearly mixed with sediment and could be a fluid that's denser than the surrounding water, which is why it's not just sort of shooting up into the water column. But that what you're focusing on right now, at least on my delayed screen, looks to me to have some fluid component to it. It doesn't
Bridge
look
nav received.
like we've seen over the years,
So ship is
at least
stable, guys.
as a non-biologist, an animal burrowing and just pushing the stuff out of the burrow. This is really, really interesting here. Adam just wrote fluid as well. I think the geo people are thinking this is some kind of fluid flow.
Interesting.
Yeah,
So in some places, we get more saline waters in the subsea floor in these places, and that more saline water would be denser than the ambient seawater. This is definitely fluid, yes.
How interesting.
This is our first good shot so far.
Yeah, Bernie just asked about brine. So the reason that you can get more saline waters coming out is that when you form gas hydrate, which is the stable phase of methane and water, at these water depths, you exclude salt. It's very similar to the process of forming ice.
On Sirius type.
So you can therefore make brine. Now, these are not the kind of brines you're going to see in the Gulf of Mexico where you have an underlying huge salt sheet, but you can make briny fluids in the subsurface as that gas hydrate forms. When it breaks down, then you release fresher waters. This is amazing footage, though. If it's possible to put the lasers on for a few seconds, it would be great to have that scale for this photo for these specific.
Can we get lasers on just in the? Yeah, that's great. Thank you.
And that Sirius cam as well is
so
quite
camera
impressive.
2, you can see the view from Sirius up above and the mound as it's in front of the vehicle.
Let's go back tight to the hole.
Good.
Yeah, this is Adam Starkey. I don't think we've ever seen anything like this at one of these sites that I can recall. This is just really remarkable to see this sort of fluid flow behavior being denser and all these tiny holes under a sort of dome. Just really curious from the standpoint of geological processes and geochemical processes that might be driving this.
You want to look for another?
I mean, it's still flowing. You can see the shadow.
We're very glad to have Carolyn and Adam on the line who have much more experience with this type of environment, and knowing that they have not observed this before in this area is really exciting.
Not this area, anywhere. I mean, we're talking Gulf of Mexico.
Okay.
Anywhere. I mean, in the Gulf of Mexico, we saw some incredible things in the Gulf of Mexico, but never seen anything like this.
So amazing.
Yeah. And when we talk about seeps, we tend to sort of be a little bit biased towards thinking of these plumes of methane gas coming out of the seafloor. But, seep can include fluids like this coming out of the seafloor. But, wow, that's just incredible.
Look at the one
right.
on the right.
Okay, so in this view that we're seeing right now, I will say this morphology, this very kind of low, hilly thing, this is very similar to the hydrate mounds, mantled hydrate mounds that we've seen in the Gulf of Mexico. We've seen them on the Pacific margin. So it would be like a thin veneer of sediment over a sort of you can think of it almost like an inflation feature with the hydrate below it. So it is very possible when you back up and you look at the morphology of this feature, I can't guarantee you what it is, but it has the look of these low hydrate mounds that we've seen in other locations with a sediment cover.
Let's go ahead and get that one tight.
Yeah, go ahead.
This is just amazing. This is unbelievable.
Yeah, there clearly has to be a pressure gradient here driving this fluid out. Some very... Oh, wow.
So, I mean, I'm almost thinking this is like a miniaturized mud volcano that you see where you get fluidized mud, except this is much more fluid than sediment. This is predominantly fluid here. This is really incredible. And like I said, my first thought might be that it could be related to gas hydrate processes right below us here. So as the hydrate forms, it excludes salt that makes the fluid more saline, and that would make effectively a more briny fluid, and that would be denser than seawater when it flows out, carrying some sediment entrained with it. But obviously we would have to sample this to know for sure.
Okay, let's get another shot.
And Carolyn, just to clarify, with D2, do you think there's a way for us to acquire a sample? Would slurping be anything of interest?
I wouldn't know what to do with it if we got it. I mean, I think this is, obviously a place that's interesting because I think there have been, 5 dives in this general area by other vehicles before, at least, maybe more. And this exact place has never been visited, but my guess is now it's going to be visited because this phenomenon is really interesting. I don't think we could do anything easy with D2, though. I'm sorry to say. No.
Yeah,
understood. I didn't know what to call it.
We can come wide on it.
Get good video, though. I mean, this video you're getting is really, really helpful for us to look at it.
If you want to lose the skids, you can, Roland.
Can you get maybe a hovering view of the whole thing from ROV? Try to slightly get out of the murk. Maybe the cleaner section upper right.
Well, it's upper slope. I'll be stuck there. That's the only issue with that. See if I can come around.
Yeah, maybe if you back out and do a pirouette around.
Alexis or Amy, I don't know if you have the screen where you can pull it up pretty quickly, but it might be worth just seeing if you see any temperature or DO anomalies around this feature right at the ROV. I don't expect you would, but it might be interesting to check it out.
Sorry, everyone. We just switched out a little bit, and you were requesting to see the CTD screen, I believe?
I was just saying it might be worth looking to see if there are any anomalies with the temperature or the DO right on the ROV at this site. I don't expect there would be, but worth taking a look.
Okay, sounds good. We'll work on that real fast. Okay, so the CTD output should be on the camera 3. I'm just checking to see if it's the same one. Nope, that's not the one that we want. Hold on a second. Okay, yeah, so it should be on, no, go ahead. You can go back to that one, Roland, sorry. Yeah, so it should be on camera 3.
Yeah, it doesn't look like there's anything there except a small perturbation in turbidity, which is exactly what we would expect with the sediment particles up in the water column.
Yep. So I came in kind of halfway through this discussion, and so what would be, I heard Carolyn talking about that okay, there's this as the hydrate is forming, it's excluding the salt, and so as the this fluid is coming out and it's more dense because it's more salty, etc. But how is it actually bubbling? What would be the force that would cause it to actually bubble out if it's more dense?
Okay.
Yeah, Amy, it's kind of I'm not sure. That's sort of something I'm puzzling over. What the pressure gradient is that would drive the brine out. It looked like from that close-up video that it was coming out under pressure, but Carolyn probably may have a better handle on it than I do in terms of what the driving force could be there.
Look at the spout.
I only caught the very end of that because Skype kicked me off after 2 hours, Adam. So unfortunately, I think you were talking about the pressure differential that could drive fluid flow.
Yeah, if it is a brine that is denser than water, then what would be the pressure gradient that would drive it out in these little sort of fountains, for lack of a better term, we're seeing here?
Yeah, I'm not sure. I mean, obviously you can get small pressure gradients even just from bathymetric variations. But I don't know if those. I would have to calculate if those would be enough to really force something like this. It's really, really interesting, though, obviously, and it makes me want to go back and look at some of our deeper imagery at this site to see if we can look at conduits a little bit better.
And I know earlier there was a lot of kind of chat about all of those little bumpy features on the seafloor. And is it possible those little clumps is from something similar to this? Or I don't know if there was any discussion of what those would be.
Center up the mound.
I'm no biologist, you guys would have to say. I mean, to me, a lot of that looks just like the kind of biological activity you see elsewhere. I don't know. I mean, this to me looks like a different kind of feature, and just generally this. Again, I'll say again. I'm sorry, I don't have any more to add at this point. This kind of morphology, this like low-rounded mound, sometimes with sediment cover. We have seen these as. You can think of them as kind of hydrate inflation mounds in a way. It's like you've got a buildup of gas hydrate underneath them that gets mantled by the sediment, and then you could have hydrate breaking down and reforming in the subsurface that can obviously have a lot of fluid stuff going, fluid-related matters going on and changes the geochemistry of those fluids. So that's what this looks like to me right now.
Okay.
And that could happen, for example, if a really kind of effusive gas sheet gets somehow mantled by sediment, and you would kind of, the vision I have is something like you're like puffing that methane in below a cover that causes it to form hydrate instead of getting into the methane reaching the seafloor, and those mounds can then build on themselves and grow. But I emphasize for any of the public listening on the line, I mean, this is a new feature for us, and this kind of this venting of fluid is a new thing for us to see, particularly in the Atlantic. So I want to just say that this is speculation just based on physical principles and what we know from experience at this point.
Right, absolutely.
I think I see one bubbling.
But I think this is also a really great example for anybody who's listening and watching of kind of the scientific process, right? And the exploratory part of this expedition that, we are seeing new things, and it leads to these questions that we're going to continue to be asking and trying to figure out long after the ROV is back on deck. Well, do we think we have some good images, and shall we carry on? Oh, before we move on, could we take a look at that crab that's to the right, please, pilots?
Yes. All right, are you good, Roland?
Yeah.
All right.
Still wondering about that hole that's on the
Yep.
corner.
Let's get the crab.
Laser's clear. Is that an urchin wearing a crab?
Just as a note, pilots, we're only about 20 meters from that next waypoint. So, after this.
Yeah, so looks like a mussel
Yeah.
actually in
There's
the
a mussel in there.
and definitely not a crab mussel.
Spiny red crab. I don't know.
Yeah.
If anyone can tell more specifically.
Hey, it's coming up.
So this is Brad Stevens says that this is a king crab, a Lithodes species, not a Chaseon. So we saw a bunch of Chaseon crabs previously, those kind of Atlantic red crabs, but this, if I remember correctly, would be kind of below their depth and temperature habitat.
It's in that mound, that dip.
No, there's a fish, and not sure what else.
Can't tell. Looks like he built himself a house or something.
Can?
Oh, it's another one of those kind of rusted out cans.
Oh, okay.
Hey, it's coming out.
More of these depressions with the fish inside.
Coming up at you, Sean.
I saw that you guys came across some really amazing mussel beds.
They were.
Did you see any active bubbles?
Not while I was on. I believe they were imaging a small bubble. Well, but I came on about noon.
Okay.
So this thing is like, what, 10 meters tall? Pretty big.
I don't know. So, pilot, we maybe should try to get a rock sample around here, if that would be at all possible.
Copy. Let's see, I'm a little stretched out here. Maybe the one with the lasers on it right now? Would that work for you, or?
I think so.
Okay.
That would be good. Thank you.
I was going to say. Yeah.
Well, we still haven't hit waypoint 6 yet. Am I good to... Can you come down a little bit and give me some tether? Okay. I mean, we can always move the ship if I'm too far out, but I think we have enough tether for that. It's a pretty big rock, but I think we'll be okay. So we don't have anything in our rock boxes, correct?
Correct. There's no samples.
Yes. So I'm guessing this is going to be pretty soft watch lead.
Yes, it is probably going to be very soft and crumbly.
Got me. Yep. Well, I moved it closer to me. Let's, I'll just move real quick.
Usually the rocks don't try to run away.
Oh yeah, it might be still rolling down there. Yeah. Well, try a different one.
I think that's it in the center.
I guess we should put this in the port box if you want to bring that in. Yeah, come on in. It might be a little big.
There we go. That's helping.
Is this gonna fit? I don't know. I don't know. I might try to
Yeah.
break this. My God. I'm making a mess here.
There's a smaller one near you now.
Yeah, that small one.
Get the smaller one.
Yeah, it'd be fine. Great, thank you.
Can you put that on port?
Port rock box.
Port rock box.
You good with hydraulics?
So, in order to get right over that waypoint.
Did you get the waypoint there? Right,
yeah.
good.
If you're ready, it's about a 15-meter move. We'd be right over it.
For Sirius?
Yes.
So I can just drive right over it. I mean, you can put a move in if you want.
Yeah, I just want to get us right over it.
Yep. Good.
Okay. Sounds good. Bridge nav. Yeah, you ready for a move? Okay, 15 meters, 1.5, at a bearing of 110, at a speed of 0.2 knots. Roger that. Okay. Yeah, it's just put us right over waypoint 6, so. Watch lead nav. Yeah, just to update you, actually D2 is actually pushing out towards waypoint 6, but we're going to move Cirrus right over it here with this next move. Watch lead 2, are you trying to call me? Ah, okay, received.
Thank you for that rock collection, pilots.
You're welcome. It's about as far as I'm going, Sean. We'll bring up on that one.
Yeah.
MB proc.
That one. This is waypoint 6. Looks like there's some mats right below you there. Just small ones, right?
Yeah, but we're looking for a bubble field here.
Yeah. We should be, like I say, we'll get Cirrus right over it.
Hey, come on in video. Hey, come on out.
Should be swinging.
Another big outcrop here. So we had a great question here from Instagram from Purple Poppy.
Want to try.
And thank you for the
this good,
compliment,
or-
saying that they've
You're
really
fine.
enjoyed
Okay.
watching the dives and seeing and learning so much and
Should be
enjoying the commentary.
Pretty close to a stop here.
Asking on the ideal dive, what is it that you would like to see or sample?
Bridge nav received.
Or, you know, what we haven't already seen or sampled. And I don't even know what an ideal dive would be. I feel like we've had so many ideal dives.
Yeah. Oh, we have a little octopus right at the bottom of the screen. Or, sorry, there's an octopus below the screen. Sorry.
Yeah, I saw him. He's
Yeah.
Oh,
down there.
yeah. Good eye.
But yeah, Amy, sorry.
Oh,
Go
no,
ahead.
no, it's fine. Always will pause for octopods. Yeah, I mean, my opinion, I feel like we've had so many ideal dives. We've seen so many things that, you know, we haven't seen before. And
Go ahead.
the octopods brooding their eggs. And, of course, our, you know, shark
It's all the
and
down tilt I
wreckfish
have.
encounter. And and then the coral dives that we've had with the amazing Lophelia and the fantastic Paragorgia. So, I don't know. I don't think I could ask for anything more.
Yeah, I think a lot of when we expect to see things, it sometimes is quite different. We come to areas where we have an idea of what might be around based on whether it's a canyon or a seep or a coral mound, but every dive we're exploring a new place, and the collections generally reflect, or we try to have them reflect the community that we're seeing in the area. So if there's a type of organism that's reoccurring that hasn't been sampled from that area before, or getting a geological representation of the rocks that we're observing, as well as if we see anything that seems really new. So every once in a while we'll see something that nobody really knows what it is, so we try and sample that so that it can be described for science.
And Brad Stevens from University of Maryland, I think, sums it up, is that we like to see something we've never seen before, which is pretty much happening on every dive.
Yeah, very true. And this is a nice little grouping of Brisingid sea stars. They generally just kind of attach onto walls or rock faces like this, and they use their arms to filter feed, which is why they're kind of out in the water column like that.
Go ahead.
Interesting that we've seen that there's a number of them on this rock, but we haven't seen many behind it.
Cup coral behind it, or is that?
Oh, I think you're right. There's a couple Desmophyllum down there too. Good eye, Amy.
Yeah, look at that. Just this little pocket.
Yeah. So that's one thing, and I think Adam talked about this a little bit earlier, is that this type of carbonate is made by, because of bacteria processing methane, and over time it's exposed, and if an area is no longer actively seeping, we often see then settlement by other types of organisms. So we see things like sea stars like this that aren't necessarily relying on the chemosynthetic environment, but they're relying on the substrate that's been made by that environment in the past. And similar with these cup corals that we just saw on that rock as well, likely they were just taking advantage of the space that had been provided and had made a new habitat for new animals.
There goes a crab.
Oh, can we see the crab? Have we seen a red crab?
No, we haven't.
Yeah, if we could get just a zoom. It's definitely
cruising along.
Yeah, going places.
Places to go, things to see.
Just like us.
That's right.
I couldn't quite tell what kind of crab that was, but maybe if Brad Stevens has an idea.
In the video world, we call those a running crab.
Hey, come on in.
Does look like a Chaseon.
And I just said about being too deep and too cold.
Every dive, we learn a little bit more.
That is very true. Every dive, we learn a little bit more.
Hey, coming up.
So, our next waypoint is almost due north.
I'm just
And,
going to look south here,
Okay.
Sean.
Okay.
Mike Vecchione had said that
Sean,
octopus
like
that we saw was
for
another
us?
musk octopus.
I was wondering if
Or Muse
pilot
octopus.
wanted
Yeah,
you to
Muse
light that area
octopus.
back there for us.
I don't know what you're asking.
If Sirius turned in that direction, then it would light it up in the distance.
I mean, I'm just seeing if there's any obvious signs of bubbles out here. Yeah, I'm coming back around.
Watch due nav, go ahead. Yeah, so going based on HYPAC's waypoints, we're right over waypoint 6. Now, obviously, you know, on the other map here, it may be a little bit off. It's probably back about just shy of where we saw that mound with the plumes. So, and waypoint 7 is due north of here, so it looks like it would take us just to the edge of that orange line on that other map. I'm sorry, to give you an idea, just east of the orange line. Yeah, is that still, we're still going to go for waypoint 7 then? Okay, received. Let me
I'm
see
already
about our
facing there.
next move here.
Yeah, you can start bringing us north, Mark.
Okay, just due north. That should work. You want to do a 30-meter move,
Sure.
or you just want to move
That's
a
fine.
short distance? Okay. Bridge nav. Received. We got just a hold for a second, guys, from bridge. Yeah, you guys good for a move? Okay. Distance 30 meters, 30, at a bearing of 000, at a speed of 0.2 knots. Roger that.
Oh, wow.
So, Mark, we typically do 30-meter moves because our tether is about 30 meters long. So if I'm stretched out, I'm going to be somewhere between 20 and 25 meters away, and then I can see out another 20 meters on my sonar. So when you move 30 meters, you're basically going to move to like right where those shells are.
Yeah. Okay.
So it's pretty safe.
Yeah, you've already looked.
Moves, right? And we don't see any cliffs on the sonar or anything like that.
Yeah.
If you do like longer moves, like 100-meter moves, you can get more layback. So then when you go to stop, say we like decide halfway through we want to sample, you stop the ship, you're going to swing past where you say, all right, stop here. Yeah. Unless you're like really shallow or you're doing a slow move. So the faster the move, the more layback you get.
Layback, yeah.
Yeah, so if we think we're going to stumble upon something, we might do 30-meter jumps.
Just keep doing 30s.
So that we can stop relatively quickly.
Yeah.
And it gets amplified the deeper you go.
Sure.
Because when you're at 3,000 meters or 4,000 meters or 6,000 meters, you put in a move, it can take 10 to 15 minutes before you even start to move on the bottom.
Yeah.
And then when you stop, it can take just as long to actually stop swinging.
Yeah.
So...
And we were seeing that in that deeper dive, yeah.
But it gets like amplified.
It keeps going.
Keeps getting stronger and stronger. So the deeper you are, the slower you end up traversing the bottom, especially if you're on a cliff. Because like you basically, when you call in that move, that's what you're going to get, and you don't have a lot of options to change that.
You're kind of committed.
Yeah, it's committed once you've started that move, basically. And that's when you'll get into like, all right, we're moving, let's stop the ship, let's move the ship back 15 meters to try to counter that layback.
Yeah.
Gets a little more complicated.
Yeah, I figured as long as you're out in front and you can see it, it's safe at that point. But I know when we were on that deeper one, you could watch it. It'd take 5-8 minutes.
Yeah. Well, it can take
and
twice
when you're
that.
deeper, that makes sense. Yep.
So it can be a little frustrating on deep dives on a cliff because it can take, a long time to get anywhere.
Yeah. Slow moves.
All right, let's come on up.
We're about halfway on this move, so.
Let's get this here.
Oh, it looks like a sea pen. Just relatively sedimented around it. One of these shorter stalk ones. I saw an umbellula earlier that has similar polyp shape, growing in a kind of similar distribution where they're kind of off of where there seems to be some active seepage, but that seepy area is not too far away.
Can I get the pink section?
The what?
The pink section to see if it's a worm or...
The pink section of what? I don't know.
The coral base.
Of the sea pen?
Yeah. It's obscured by the coral now.
Okay, come on out. I'm just going to push out here, Sean. Just take a look on this side. Just copy. Yep, toes in. Let's come on in, Roland.
Oh, it looks like hollow down there. So interesting.
Drawing the extra lights.
Yeah, you can try it. I don't know if it's going to do much.
It's one deep hole.
Yeah, pretty serious burrow. Thanks,
Yeah,
pilot.
it's coming out. Let's kill the lights.
Yeah, ship's coming into position here.
Another one of those big picnogonids off to the right.
Yeah, I've seen, again, a number of those kind of just walking around off of the seeps here.
Yeah.
Cup.
It's good seeing some
yeah.
mussel debris.
I think we're going in the right direction.
I think we are going in the right direction.
Just gonna look off the port here, Sean. Copy.
Another rock up there in the upper right.
Sure.
Yeah, we should be stopped here, so.
So this is basically right in our path, right, Sean?
Yeah. So you want to go ahead and move in on it? You're stretched out right
Yeah,
now?
just keep heading towards that waypoint.
Okay. Bridge nav.
Yeah,
yes,
another
ready
big
for another
area
move?
with these outcrops as well as
Distance 30 meters,
a
30,
lot of shell
bearing
rubble.
000,
We'll take a look at
at a speed of 0.2
rocks
knots.
around the rocks to see if we see live mussels. We're not seeing a mussel bed per se, but
Roger that. Thank you.
definitely could be some live ones.
Okay.
Definitely evidence of some, previous seeps here, probably at one point.
Interesting change in sediment color. It doesn't, that's not bacteria, right? Or is it?
Oh, might be.
Oh yeah. I think it is. Can we just take a zoom on this?
Alright, come on in video.
It looks like more of those holes that were
kind of venting out.
right
Yeah.
on that mound area, which also had that lighter colored sediment. So maybe at some point this one is also, that fluid flow is coming out. We're not seeing the cloudiness from the sediment being carried.
Yeah, but that's... looks like these little kind of mini kind of mud volcano type features that
Right.
Carolyn was talking about.
I can see a little bit of shadowing.
Can you? Is it?
So
Does it?
I think that's. I think it actually has fluid coming out.
Oh, it does. It looks...
Oh, I see what you're talking about.
Yeah, I think we're seeing exactly the same type of feature again here.
Yeah, the one on the top center.
Which is really surprising. It's
making a shadow.
It's amazing to find one, but really notable. There seems to be multiple features like this around this part of the Seep field.
Come out just a little bit.
Yeah, and thank you for pointing out the sort of mini mud volcanoes. With the screen I was on, I didn't really see it in 3D until you said that. And so it is interesting. There's like these little constructional mounds around each of these holes. I mean, I guess not being a biologist, I would have often thought that you see that associated biological activity. But of course, before when we saw this, it very much looked like a sort of more physics-based activity with the fluids flowing out.
Josh, I wonder also if we can go downhill and shoot up at it.
Yeah, it definitely looks like there is some flowing out of some of these, just not at nearly with the same vigor as at that other mound that we saw.
Yeah, I know. Would be nice to have a push core right now, but definitely provides a reason for people to come back to really get a further investigation as far as what these little mounds and this kind of either fluid flow or whether there are organisms down in these little tiny burrows. Might be interesting.
Yeah.
Definitely interesting to come back and take a closer look at.
I think there's fluid coming out of these.
Not to give you too much of an advertisement here, but I mean, obviously, that's been something very powerful about the whole OER program is the way that the imagery, and even without being able to sample sometimes in the previous years, has really catalyzed a lot of the science that has come since. And we've certainly seen that on the Atlantic margin, because the entire Seep story was actually based on work done by the Okeanos and then the initial dives that have spawned so many cruises by myself and others and many of the ecology groups over the years. I mean, I think I counted this morning 5 different U.S. government agencies at least have been involved in research out here since that initial discovery.
Yeah, that's really great. Thank you for pointing that out, Carolyn. You know, as we mentioned before, this is the 100th expedition, 10 years of the Okeanos Explorer, and it's the only federally funded research vessel dedicated to ocean exploration.
Sustaining.
Watch lead nav.
Yeah,
Go ahead, Nav.
Yeah, I want to let you know D2's moved out another 100 meters. We're at the 700 meter mark.
Thank you.
Can you maybe light it for Sirius?
Bridge nav, go ahead.
I've seen some of these other really kind of light colored patches that we haven't zoomed in on. Makes me wonder if there have been more of these.
that one was just so pronounced that
Yeah.
it definitely caught our attention. But
Guys, they may have to make a slight heading change on the ship here.
kind of being able to look at that one and then see if we can see
That
similarities
move
as we
just
go in other
completed,
areas.
So I'm going to assume you're probably still
How
swinging
much of
a
a
little bit.
heading change are they doing?
Not sure yet. They haven't come back yet. The winds have picked up a little bit. We're a little bit over 10, 12. Yeah. Yeah, and the current shifted a little more south. So hasn't picked up a lot, but just a little bit of a change. Yeah. You can feel the ship working at it here.
Amanda Demopoulos had sent me a note earlier that I just am looking at now. That her lab recently, her lab and the other collaborators from the Canyons work had published a study from Norfolk and Baltimore Seeps. They published it this year in 2019, and that the one Heckeri that Cheryl Morrison had talked about earlier was actually isotopically distinct from the Childresi, so all the other mussels in the surrounding area, suggesting potential nutritional roles for both methonotrophs, so the Childresi, and the Heckeri would actually be processing sulfur oxidizing bacteria. So that's really interesting, and I think another reason to see to kind of, as we see those larger mussels, really note them, because there's two different types of bacteria contributing to those communities.
Yeah, that is a really interesting observation that they have.
A little hot here, Roland.
It's that bright white thing up the right.
Let's do a quick zoom here. Sold that. Yeah, it's coming out.
Looks like they're coming around now.
Oh yeah, more of these
kind of plumes of...
Yeah, different type of plume.
This is wild.
Come on in, video.
I think it's also part of the utility of having this be live stream and all of our scientists on the shore is that you have so many different people with all of their different experience being able to contribute to kind of what's been seen before, if this hasn't been seen before, versus, you know, the primary group of scientists that are often on a research vessel, which is just a much smaller group. Oh, okay, this is different still than what we were seeing.
This is Carolyn. Okay, so I'm going to say that, and Bob Carney's in the chat room, so maybe he can weigh in as well. So when I've seen briny flows, and I'm not saying these are at the levels when they actually would be technically brine, but when I've seen them in the Gulf of Mexico, I mean, they are usually flowing sort of more laterally like this.
After they finish that, you want to go ahead and
I've got to believe, and you see that sort of hummocky, very low bathymetry there again. I've got to believe that we're looking at some sort of geochemically altered fluid here. Obviously, it can't just be seawater circulating through here. We've got to have altered it in some way that it's flowing out like that.
Is that more of the...
No, I completely agree with you, Carolyn.
Don't know.
come on in, Roland.
Yeah, this is more interesting because we're not sort of seeing the source of it like we were at those other little mounds. So I guess that one maybe. But it's not acting in the same way as sort of that mud volcano.
It could just be how much loose sediment is available to be entrained, right? As these things emit fluid. So you've got to have sediment of a certain grain size and a certain sort of abundance to entrain it. If it's, for example, if grain size is too large, it's not going to get entrained.
Right. Yep, that's a good point.
Soft white or grayish patch on the left, past the white.
Yeah, and I'm, oops.
Bridge nav, go ahead. Yeah, I received. It looked like winds
Sorry, I
picked
think
up a
the
little
ship was
bit,
going to
or
say something. Sorry, I hope I'm
any
not
other
interrupting. But this is Carolyn again. One thing I should say is, I mean, we do have seismic data across this area, and whereas the Blake Ridge Seep, which is the one some of us were working on 20 years ago now, or even longer, or 25 years ago, the Blake Ridge area, there are salt biopiers down there, and those are remnant from the opening of the Atlantic Ocean up many hundreds of millions of years ago. Whereas in this area, we don't have evidence for salt biopiers at depth. So even if we are seeing a sort of more briny fluid come out at the seafloor, it is not coming from a sort of dissolution of the salt biopier at depth, the way that we think of some of the salt tectonics that we see in the northern Gulf of Mexico.
We can keep moving.
So, still good with we'll just go due north. Slightly off to the target, but okay.
And it looks like we are seeing some more bacterial mats
due north,
here.
30 meters. Okay.
Maybe.
Bridge nav. Yeah, ready for a move. 30 meters, 30, at a bearing of 000, at a speed of 0.2 knots.
Yeah, if we could get a snap of some of these kind of vent holes here, please.
Come on in, video.
Roger that. Thank you.
Put lasers on.
Yeah, it's interesting too because we've been seeing these holes in the ground throughout the dive, and I've assumed them to be made by an animal, but these ones seem to have some of this fluid coming out, so that I think raises the question of really possibly the origin of the holes. Is it actually geophysical versus biological, which I think it totally might be.
Video's clear.
It's come out partial. Yeah, to the right. This guy. Yeah. Thank you. It's appreciated. Yeah, let's come on out.
Yeah, some type of cable that's running along the floor there. We'll make sure to be cautious as our pilots work their way through. Definitely glad that we have good visibility and not a lot of turbidity in the water today as we're observing these kind of fluid flows coming out of the seafloor. Be quite difficult to observe that if we were in different conditions. So it's a nice, just a quick observation considering some of our last dives, which were in more significant canyons, we had quite dense turbidity layers down there.
Yeah, and even though it looks a little stirred up down here from some of these features that we're seeing, if you look at the Sirius cam in camera 2, you can see that in general the water is quite clear. There's not a lot of turbidity or organic matter in the water column.
A soda can next to possibly a xenophyophore, which is like a type of foram. They've been talking about them in the chat a bit. We've seen some of these along the seafloor in this region.
It's coming out.
Another one of those spoon worms.
Just do a quick snap.
It's the proboscis of a worm that is extended out of the hole, and then it will retract it, and the worm is deep down in there and has a nice meal.
Right, coming up.
Can you rotate, can we just take a look at that little mound right there below the lasers,
Come on in.
please?
Just come on in, Roland.
Just wanted to see if there was any evidence of any kind of fluid flow. Thank you. We can come out.
Yeah, copy that. Alright, come on out, Roland. How you doing, Sean?
We're just about done with the last move.
You want to fly for a bit?
There's some more of those holes, huh?
Do a quick zoom here. Go ahead.
Thought we were going for the floppy thing in the bottom.
This guy. Oh, it's a shell.
I thought it was something else too, Pilot.
Yeah,
So yeah.
I was like, Holothorian? What is it?
I think that floppy thing in the lower left.
Yeah, there's something waving around.
Go ahead.
Oh, maybe a hydroid? It's a very strange base. There's a lot of like white pockets. Interesting. I'm not sure what that is, but we can carry on.
Right, just take a quick snap all the way in. Ah, sorry.
It looks very squishy.
Just can you sort of follow up with it?
I have nothing.
Ship should be coming to a stop on the last move.
Go full screen from here.
Yeah, go ahead. Alright, just coming out. Okay, let's move on. Copy.
Yeah, and I think the ship is stabilizing at this point from that last move.
I feel like I've never been more sensitive to watching sediment movement in the water. Now that I realize it could potentially be coming from the fluid flow from the seafloor. Not this, but still.
I don't think I caused this.
Oh, what? Really?
I don't, maybe. I don't know. But I haven't been over here, so.
Let's see if it looks like it's sourcing from anywhere. No.
This is probably me.
Okay.
At this point.
Gotcha.
I've been pushing around quite a bit here.
Yeah, thanks.
You doing donuts in D2?
Well, I've been carrying some dust along with me.
Oh, okay.
Yeah, pushing out, Sean.
And the ship's just stabilizing from that last move, it looks like.
Let's do a quick zoom here. Just come on in.
Hang here.
You going for the nodules?
Yeah, just come in tight here.
Yeah, that fogginess.
See, like the fogginess there, that's not me.
Right.
drop a target on this, but what do you want me to call it?
I wouldn't worry about this. It's very small.
Okay.
Yeah, some of those knobby things are definitely xenophyophores. I don't think it's not all of them, but
What's that, Sean?
it's definitely a number of them when
Are
we
we
do
done
those
with that
close
move?
zooms.
Yes.
Yeah, we
the
can put another one in.
ship's just been stabilizing a little bit, but yeah, we're good. Ready for a move. I'll get it in. Bridge nav. Yeah, it looks like we're done with that move. You ready for another one? Okay, distance 30 meters, 30, at a bearing of 000, at a speed of 0.2 knots. Roger that.
I can't hear you. I'm sorry.
Oh, I'm sorry.
No, I'm talking to Mark.
So it's kind of empty until we get up to that waypoint as far as on
as far
the map.
as Seeps, yeah.
Yeah. I know we've got the other features, but just kind of giving you what we're seeing on this compared to where we are here.
Get the swimmer here.
They wanted to try to collect one of those the other day.
Another one of these swimming holothorians. So this is a swimming sea cucumber. We saw a whole bunch of these a few days ago. They can wriggle their body back and forth like this to move from place to place.
Yeah, and then they feed on sediment on the seafloor, so also pretty interesting to find one around this area. A different type of sea cucumber than the ones that we know are associated with mussel beds.
Let's get center here. Okay.
An orange anemone and a sea cucumber just up by the lasers as well.
Man, they do hide well.
All right, let's come on out.
So again, this is not from us, correct, pilot?
It's hard to tell. I mean, it's possible that the sediment is so fine that when I turn, it's enough to kick this stuff up.
Okay.
I mean, we can do some experimentation. But I think it's probably from us.
So, science leads, you're obviously looking at this sediment plumes coming up the seafloor and I guess what you're implying is that it's probably not just the current picking up fine sediment. It's maybe what we saw before with fluid flow coming out of these holes and training fine sediment as it emerges.
Right. We're trying to figure out if that was it or if it was just from the ROV being near the bottom and kicking up some sediment.
Copy, I'm coming back around too.
Bridge nav received. Thank you. The last move was complete, and just as a heads up, as we've moved up here a little bit, the waypoint's just a little off, so maybe 10 degrees. So let you see what you see, pilot.
What's that?
You know, the waypoint's a little bit.
Yeah, that's
10
fine.
degrees. You know, but let you see what you see, and then.
No, I mean, I can tell you that's
fine.
Fine.
Yeah,
it's fine right
okay.
now. So.
Okay. Yeah, last move just completed, so I didn't know if you wanted to swing a little bit or you just want to keep moving.
You can keep moving.
Okay. Bridge nav. Ready for another move. Distance 30 meters, 30, at a bearing of 010 at a speed of 0.2 knots. Roger that. Thank you. Watch 2 now. Go ahead. I was actually going to check that here in just a second. Stand by 1. Got about an hour, so watch 2 nav. It looks like a little bit over an hour. Roger that.
So we have, yeah, so down to the lower right. Yep, right there on the bottom of the screen, that white brown thing.
We'll just take a quick look at that.
Go ahead and.
Oh, no. We both thought it was, in that case, it's
Yeah.
a mussel shell. Never mind.
Come on out.
Those off-road arms tricked us.
Yeah, and we both had the same reaction of, I guess because we had it in our heads, we saw a bunch of them yesterday.
There's a halosaur in front of us as well.
Let's come on in.
It does look like we have
Over
an
here.
octopus.
It does.
come on in,
Another
video.
muse octopus, I believe. Well, that's early to call. I should wait till we get there.
Hey, Roland, let's come on in.
Sounds like a very reasonable
Does look like a muse octopus. They talked earlier, Mike Vecchione, about the counter shading. So often light on the top and the mantle of the octopus, and then they have the really dark
Let's get lasers
tentacles.
on and clear the lasers.
We've seen a couple of these today. Just on
I guess
the
that's a
seafloor.
very common kind of defense position, to sit there with its arms curled up. And I mean, it had been sitting there like that well before we approached it.
Yeah, Scott France makes a interesting comment, and it's right next to the octopus is a xenophyophore, the
kind of honeycomb looking
yes,
thing.
that's a good description. And those xenos are single-celled organisms that build that structure, and so you have this very evolved complex octopus next to this single cell.
Yeah, I remember them talking about the arms and the body are different color. I got a little bit of tilt left.
Just completing a quick pilot change here as well.
Is the ship stopped or moving?
And to quote Scott France from earlier, that these octopods can be very amusing.
Still moving a little, but until right now.
That was all Scott.
6-0, copy. Come in, video. I'll try to hold that for a second.
Great, thank you.
Okay, watch these. We're going to keep moving.
Yeah.
Yes. Okay. Copy.
Yeah, so we have about an hour, just under an hour left of bottom time on this dive. This is dive 19 of the Windows to the Deep 2019 expedition on the Okeanos Explorer. And if you are just catching us for the last bit of our dive, we are about 85 miles off the coast of Norfolk, Virginia, at a Seep site. We have seen a number of these Bathymodalus mussels beds and have seen a few octopods that we just saw, a whole bunch of fish, and some really interesting and puzzling fluid flow coming from beneath the sediment. And my name is Amy Wagner, and I am your geology science lead on this expedition.
And I'm Alexis Weinig. I've been the biology science lead on this expedition.
I didn't hear. I didn't hear. Go ahead, watch two. Yeah, absolutely. Sitting in the front row, operating the ROV. Sitting pilot is Levi Unima.
Sitting co-pilot Jeffrey Lanning.
Navigator Jim Myers.
And in the far corner is Roland Bryan of video.
And in the back row, Brian Doros at clipping.
And we are all from the Global Foundation for Ocean Exploration, or GFOE.
Thank you, pilots in video. These are a wonderful team of engineers and videographers that are piloting the ROV, doing all of the navigation, streaming the live coverage out to the public and other scientists, and you know, has been a pleasure to sail with all of them on this expedition.
Yes, it has.
This is the 100th expedition on the Okeanos Explorer in 10 years of service. And
looks like I'm pretty stretched out.
it's always something new and exciting to find on the deep sea floor and in the midwater that we are finding.
They've been doing, it's fine with me.
Sounds good to me.
30?
I do 40.
40.
Make some tracks here. Copy mission. Just gonna do some exploratory research to our starboard side here as we get the ship moving.
Bridge ROV nav. Yeah, I'd like to request a move. Range 40 meters. Bearing 015 degrees. Speed 2 knots. And it's good to be here. Good copy, thank you.
You can snap on this red subject.
Watch lead ROV nav.
Like
D2 is past the 800 meter mark.
You can become wide video.
fish.
Copy. Zoom in partial, yeah.
Is that a cyclothony? Video's clear.
Copy.
See that particulate in the water?
Yeah.
We've been finding that's actually coming up from the little mud volcanoes.
Really?
So if you track that, you might find a light gray patch.
I'll go for it. Some sort of fish out there. Lurking in the darkness.
Looks like a snaffle-blanket eel. Possibly.
Go for the head.
You guys like to test me, huh?
Yep. It's coming right at me, huh?
Yes, he is.
I'll let it go pretty soon. Okay. Next video. Turn back around towards waypoint 7. Yeah, I don't think we've seen any today yet.
It's another one of those, couple of these really
Possibly red
large
ctenophore bottom right.
holes.
Yeah, really deep and
Wide.
yeah.
Yeah, I had earlier thought they would maybe be created by something biological, but we saw some of that fluid flow coming out of one earlier.
I'll leave them off.
Just makes me
Okay.
question
You
if
come in.
that's
This would-
actually
yeah, red something.
geophysical versus
Hit the
biological.
Yeah.
It's a shrimp, I think. Yeah.
Oh. Shrimp.
Shrimp abdomen.
The lack of it, yeah.
Yeah.
Maybe a molt of a shrimp also. Yeah, we're working our way towards waypoint 7, where we have another area that we had located through multi-beam, working our way upslope. So we are currently at 1,534 meters.
See a fish up here. Something white. And when that moves down, I think we could probably get another one. Keep moving. A video can come in. Oh, a little urchin or an enemy? Oh, urchin.
Looks like a urchin
Copy,
and
Bridge,
a
thank you.
halosaur.
Same again?
Yeah. If you want to zoom in more, you can.
Yep. Just waiting for him to center.
Bridge ROV nav. I'd like to request to move, range 40 meters, bearing 015 degrees, speed decimal 2 knots.
Let him go.
Good copy, thank you.
Okay. Checking out my sonar, nothing too hard out there. A couple more of these holes. I don't see anyone home.
Nope. We haven't seen anybody in any of those today.
What's this red floating subject? Did you come in? It's right in the center, I think.
It's like a Keatignath. It's a small midwater organism. Normally when they're startled, they start swimming very fast.
We'll let it go, video.
Yeah, don't they call them arrowworms or something?
I think so,
like that?
yeah. That's the common name.
We saw
Is
one
that a big
earlier.
ship near the hole?
You can snap in. This guy? Looks like a rock, isn't it?
Not a ship.
Some mussel shells.
Let's find more mussels before we head home.
Come in partial. Come in more. max on my rotator, backing up a little bit. Take more zoom if you'd like. I'll try
As
to
most as I can get.
Okay.
Till you centering. Now he's got his face away from us, so this is good.
Okay. Copy. Watching our sonars, keeping the moves coming. How far are we from waypoint 7, Nav?
45 meters.
Copy.
Shoot a few more dead mussel shells. Looks like maybe some bacterial mat coming up.
And kind of a little depression there. It's a ctenophore coming into view in our camera.
Yeah, it is a depression. You're right.
Surrounded by some of those bacterial mats.
No bubbles yet.
No bubbles.
Would you like a zoom of this bacteria mat, or should we keep
I think
moving?
we can keep moving on.
Copy. On the move.
It's good lighting on Sirius. Mind if I push in to get a shot to clip out for the day? You can center on your vehicle.
What is that? A can? Bottle?
Yeah, it looks like a bottle.
Copy. Thanks, Roland. Oh. Ctenophore hanging out with us.
Copy bridge, thank you.
How we doing, Bob? Very good.
We're 30 meters from that waypoint.
Copy. Go around this cloud here. Looks like I'm looking where waypoint 7 is, right? Waypoint 7 is 20, 30 meters away from me, my sonar. Looking right at waypoint 7 here. Approaching.
Okay, then once we hit 7, I think we can kind of look on the sonar, see if you see anything that sticks out, but if not, we'll just head on to waypoint 8.
Copy. Haven't seen anything yet, but we're not. Yeah. Let's see here.
Yeah, it looks like we're going to kind of come up onto a flatter area, and hopefully we'll see some bubbles in the sonar. Pilot, you tend to bring us good luck at the end of dives, so.
Copy that. Yeah, we got the big corals.
That's right.
Shark.
Yeah, you've had a lot of good shifts.
All right, so that's off to my starboard. No, nothing over there. I'm gonna turn back to my port to look directly where the waypoint is dropped. Nothing sticking out to me. How about you, co-pilot? Looks like the next waypoint is the same direction, so we could maybe keep marching that way. Yeah. And check my port side here, just make sure I'm not missing anything.
Bridge RP nav. I'd like to request a move, range 30 meters, bearing 015 degrees, speed 0.2 knots. Good copy, thank you.
Yeah, watch lead. I just looked all around me. I've not seen any hard targets yet. We're going to keep moving.
Sounds good.
We have 35 minutes of bottom time left.
Waypoint 8 or bust.
I mean, we did already find some really good stuff today.
That's true. Copy.
Yeah.
Bring my tail towards you. We'll look at this sea star that's buried here while we wait.
Yeah, I think this is the first one that I've seen today.
Come in video. I'll wait here for the ship.
I think we saw some of these previously that like to bury themselves with just their feet and middle of their body sticking up out of the sediment. And science is clear whenever video is.
Copy. All right, thanks.
think I'm feeling that move. See a little slack in the
So
tether.
that was in
Copy.
Still
Astropectinae
out there a
Day.
little ways. Give me some time to catch up.
Yeah.
If we really go
Starfish.
anywhere.
What's this video? Come in, like red in color.
Oh, it's another sea pen. It's very similar to the umbellella, but it's not on a tall stalk.
Huh. Yeah. Okay. Get you a better look video. Hold on. How much you got left in that move?
Yeah, can you easy stop on that move?
Bridge ROV nav. I'd like to request an easy stop, please. Thank you.
Okay, pilot, if
Yeah.
possible, we would like to try to suction sample this.
Copy. Absolutely. Thanks. Looks like you got hydraulics up.
Affirmative.
I think jar 1 would be a good candidate.
Copy. Jar 1. Come up. Tilt them down. We stop the ship. Should be just a bit of swing more. Let me know if you want your mini up.
Yeah, I would like the mini.
Okay. There's your mini. Delta 15. Camera is at 53. All looks well.
I noticed I'm moving as well. Alright. Can zoom in on minis.
So sand, I'm going to start at 800 and see if we can get it with that. See if you can do a little like, get it free maybe or something. And
Just
come up on the mini.
Do some manipulation first.
Better angle.
Yeah, you can come up a bump on the mini. You can come in on Zeus as well, video, when you have a second. Yeah. Okay. Small little guy, isn't it?
The mini and a little runaway. I'm trying to bring it back down for you.
Alright.
How's that?
Perfect.
Oh yeah, it's good. It's ready. Ready for some suction?
Yeah.
Getting a lot of sand. nice. Yep.
Oh,
it's still there.
Oh, really?
Yep.
Where is its roots going?
Straight down, probably.
Yeah, it's really in there.
Killing suction for a second.
Oh, blow it out?
No, just switch jars. We can blow it out later. Unless, I don't know. Actually, do you want to collect? Do you want to? We were going to switch to bucket 2, so there's a lot less sand. But if there's something in the sand that you wanted, we can just keep collecting this way. Same bucket. I don't know if there's worms or something that might be
No,
interesting.
I mean, it looks like you have a little bit, but yeah, you can go ahead and switch to a different canister. It's fine. Thank you.
Yeah, I think maybe make a little more effort to get it
Yeah.
loosened up first.
I didn't realize this was going to have like a little root action, you know?
Yeah.
Yeah, and pilots, Scott France has said that it has an inflated base, so yeah, it looks like kind of getting in there and sort of digging underneath it a little bit may be helpful.
Yeah, so you can't do it too tight of an angle, but come down a little. Yeah, like that, maybe. I know you don't want to pinch the hose end. But yeah. Like that. Can you reach pretty good? Out there towards the end of your wrist, or your end of your, it'd be helpful to move in a little closer.
Yeah, my elbow.
Yeah.
What you're going to want to do...
Came down on the mini just so you can get an idea.
Oh, okay, yeah. Great.
That's probably pretty good. Back up on the mini. See that simul zoom? It's pretty fancy. Videoing. How's that?
Concerned I'm going to lose visual of it. I took some sediment, but I can't tell if it's in the end of the end effector or if it's still sitting on the ground.
I didn't see it come loose.
You blow a little bit on the motor.
Yeah, here it comes.
I don't see it anymore. I don't know if it got like pushed under.
It's
right here, I think.
See it? It's just right in the hole there. Here, I'll keep this on. Just point it close by. You ready?
You want to blow, you're saying?
Yeah.
Yeah.
Just blow away some of the dust. You can see it there?
Oh. I think I see it faintly. Oh, yeah.
All right.
All right, I'll start sucking. I think I still see red in there. Do you see it too?
Yeah, it's still in there.
Where is its root system going?
Nav bridge is calling.
ROV nav. Confirm. Thank you.
Okay, you can see a lot more of the stem now. You see it down there?
Yeah.
We're just clearing out all the dirt below it, so you might as well just keep doing what you're doing. See if you can clean it out.
Copy.
It's very clayey down where it is. I wonder if now that you've cleared this out, if you could just go in for the snip, unless they want the whole peduncle. I can increase a little if you want to see what that does. Try to condense it. That's not really doing anything.
Pretty deep there, huh? Wow. He goes pretty deep. How is it? Look at that.
Much deeper than we expected.
Look at that little guy.
Can you just grab it now that it's sort of cleared out?
Yeah.
It's a hard stem, it seems.
Yeah, I think if you guys want to try grabbing it, that's maybe our next best option.
Oh, it's in there.
Oh.
Hold on.
Whoa.
Hold on.
Right.
Oh.
Oh.
Oh, we got
in
something.
Yep. Got it.
All right.
It's in there.
Okay.
Peduncle and all. I see peduncle.
It's
very
the
small peduncle.
Peduncle and all have made it into the
Surprised.
section sample.
That's really great.
Okay, I'm going to give you a little reverse here.
How
I'm going
much?
to go to 6.
Yeah, great job, pilot.
Thanks. A little bit of excavation on that one, huh?
Yeah, we have a sediment sample to go with it, so that's great.
And
Yeah, and so it has been discussed that this is
wide on the
a
cameras, probably.
Yeah, you can come wide video.
Belumnum.
Yeah, I don't know how to say that one.
And we collected this because we've seen a few of these, and that there are no previous records of any of these being collected on any RV cruises because they are so small and you can't get them with the manipulator arm. So trying to collect a specimen using that suction sampler.
Give you the other view.
Cophobelemnon.
You could see how much ground I had to excavate to get that little guy.
Cophobelemnon. Scott spelled out the pronunciation for us, so I think Amy and I will both remember that one for a long time.
Try to clear the hose.
Yeah, just push out a little, get away from that cloud.
Alright.
Somehow the cloud accumulated on the other side of you, not on the prop side, which is kind of strange. Yeah, see it?
Oh, yeah.
But, alright, here it goes.
Clean her out.
So we have some very excited folks that we were able to collect that specimen, so thank you very much, pilots.
Yeah, absolutely. We're here all day. For the rest of the day.
We'll clean out the filter for you.
I'm wondering if I should like you said, try to come straight down on it like a course, but then like you lose visual, you know. I don't know.
Just give the tube a shake when you're comfortable.
You can draw out, right?
Just shake it around a little bit, and then that helps loosen up any other stuff that's in the hose. Yeah. Very nice. Okay. I'll extend the drawer here.
Watch leads ROV nav. D2 just past 900 meters.
Thank you, Nav.
Draw out. I'm going to bring the suction back down to 0.
And Jim Masterson had asked just now, is this the first expedition that D2 has been outfitted with a suction sampler? And yes, this is the first time out where with the vehicle, with the suction sampler.
Can you extend a little further?
Functioning, and we have made good use of it, I think, throughout this expedition.
Yeah, it's been really great. We've been able to get some of these softer things that we couldn't previously grab with the manipulator arm, and then also these types of smaller organisms. So it's been a really nice addition.
How's the hose look? It looked like it was falling when I was riding in.
I'll clear it up.
Oh, that looks good.
It's good. Yeah. It looks pretty close to the gate.
Yeah, it's touching the gate there on the lower.
Probably get a move in, maybe. One last move.
They haven't called in.
Oh, heading
completed
change.
their heading change.
Copy.
We have 15 minutes of bottom time left.
Copy. 1-5.
Huh. Still at 2300 PSI, even though I turned the pump down.
Looks pretty good.
Still holding up.
Nav. Copy. Thank you, Bridge.
All right, Biddy, you can come in. Just curious what this is. It.
It's like trash.
Oh, sorry. All right. All right, you can come out. Keep going. I'm ready for a move. If
30?
If you guys are, yeah.
At 015.
Yeah.
Bridge ROV nav. I'd like to request a move. Range 30 meters. Bearing 015 degrees. Speed decimal 2 knots. Good copy. Thank you.
So we're still seeing some mussel shells, but we haven't seen live mussels or authigenic carbonate on this kind of second half of the track. We're just going to continue on towards waypoint 8, our final waypoint for the dive, for our last about 10 minutes of bottom time.
Altitude 15, delta 17. So it looks like you're going a little downhill right now.
Copy.
Yeah,
And I
you're
think I've
facing
learned
downhill.
in
It's kind of
my
along the contour to 8.
3 weeks out here
Might just hang out
that, you know, to expect the unexpected.
True. Could we take just a quick zoom on
Yeah.
that?
I'll sit down. We're waiting for the ship to move so we can get a good look at this.
They are just a group of dead Bathymodiolus.
Come in a little bit, Biddy. I'll back up and get you centered here.
And one of those white urchins we've seen on some of the live mussels as well. But when you guys are ready, we can keep going.
Okay. All right. Pilots. Yeah. Where? Left. I think it was the come in. I think it's the shell, isn't it? That?
Yeah, it looks like another
Yeah, I guess
mussel shell.
Oh. Copy. Thanks. Some more trash. Possible can.
Yeah, it looks like another can.
Mm-hmm.
Oh, those are just shells. Come in. Oh, it's shell. Yeah, stay wide. Optical illusion got me.
Shell and a brittle star.
Yeah. Couple of enemies. Last dive, last day. Looks like some coming in partial. Some trash and a fish. Or is that a shell? Oh, open shell. Shellfish.
Good one. Actually, that looks like a clam shell right in front of it, which is actually kind of surprising. We don't normally see clams around these active seeps. Or at least not like on the mid-Atlantic ones. So if we can just do a close-up of that shell.
Go for it.
With lasers on, please, when you're done.
Yep.
ROV nav. Copy. Thank you.
You can zoom out and grab some lasers with it. Not too big.
So Bob Carney and Jim Masterson both suggested that this could be a dead leucinage clam.
You can zoom out a little bit. Grab the, yeah, there we go. My right toe kicked up a little dust. Think we got time for one more or not? Yeah. I don't know if we're going to make it that far, but. Copy. Ship move. I dare you to call it in. Alright, let's explore to our starboard here.
Copy.
You snapped this video as white subject?
Oh.
Just curious.
We have, I'm sorry, missed 3 minutes.
It's like trash cut on a stick.
Yeah, some more trash with ophiroids and xenos next to it.
Oh, copy 3. What is that? Is that like a large Brazingit? What is that?
That's what it looks
Yeah,
like.
it looks like a Brisingid just on the sediment, which is rather unusual for them.
That's large too, right?
Yeah, they can get pretty big.
Wow.
There's a couple of small fish
Could zoom in.
hanging around it as well.
Lone Brazingit.
Yeah, because they're not mobile like other sea stars, are they?
They can move. They don't like fly like crinoids do, but they are able to reposition themselves.
Oh, okay.
Zoom out just a little bit. Getting nice and close to it.
It is rather large, actually.
Mm-hmm.
You can zoom in video. Go for detail. I remember they're not. Is that the one that had the arms eject occasionally? Sorry, video.
Oh wow, it's a great close-up of those arms.
Oh. You start stowing arms if it's that time.
If we could just put lasers on the way out. Sorry. Thank you. Thank you.
Yeah. I think that's the biggest one I've ever seen.
You did find something great at the end there, Levi.
Thank you.
Hey, this is Chris Ma.
Hi, Chris Ma.
Hey, I just overheard a little bit of your talk and saw the Brisingid, and I'm not sure what this is exactly because Brisingids are hard to see from imagery, but I just thought I would mention that one of the Brisingids with the greatest arm span is Midgardia xanderos, which is known from the southern Gulf of Mexico, so plausibly this could be something similar. But a lot of Brisingids can have arm spans that can get to be almost 2.5 feet across. The problem, of course, is that when you collect them in trawls, they historically come back sort of trashed and severely damaged. So getting a good estimate for exactly how large they are is... oh, this is a nice one.
Is that common for them to put their arms down like that?
They, based on my experience, your earlier statements were correct. They can put their arms down. If the current isn't desirable, they can put their arms down, and then they will move like conventional sea stars. So all of the tube feet that are on the bottom, just sort of trundle along, and they don't move very well. They're really best when they're just sort of standing still with all of their arms up in the water. But they can reposition themselves, and they can go to different places where the current better suits their feeding mode. I've actually seen some time-lapse video of them do that, and it coincides with the extent to which there's a favorable current flow, sort of moving around their arms and such. So it's interesting because for a long time people thought that the bottom life was only typical for one of the subfamilies, the Phragalidae, Phragala and Phrastra, and those are clearly Brisingid, like in the Brisingidae, so Midgardia or Brisinga. So a lot of imagery like this is dispelling a lot of the earlier notions that people had based on still photos and and badly damaged specimens. So that's a great thing for video, and I've been talking to a lot of people lately about the boon of how these videos have provided us with greater insight into these deep-sea species, as the sponge feeding video has been making the rounds quite a bit on media lately. So I'm really happy to see even my humble Brisingids again on screen. That was a group I started with my master's degree back in the day in the old 90s and such. So
should have called into the bridge.
Anyway, I wanted to thank you for both of you for being the delightful and informative narrators that you've been on this cruise, and to all the pilots and whatnot. I look forward to the next one. Thank you.
Thanks, Chris.
Yeah, thanks, Chris.
No, it's because on the service. He's on a
You guys have a good trip back. Bye-bye.
Bye-bye.
Oh, yeah. No, you're good. He's got this. He's got the checklist, right?
Cheer.
Yeah.
Cheer. Yeah.
He's got the checklist. Good job. Next question. All right.
Copy.
So, as you might have seen as we came off the seafloor, we have begun the ascent for today's dive, which was our last dive for the Windows to the Deep 2019 expedition. We were diving today at a deep seep off of Norfolk Canyon, and we had some really great bacterial mats and large carbonate outcrops that had never been observed before.